So basically the point here is that nothing grew into the canopy in the years that we did this trial. These were the tallest plants. This is the average here. These are the tallest. So that was good. One thing I will note, you will see, especially since I'm the first talk of the day, we can do the little statistics thing. What are all those letters doing in that chart? So when we run the statistics to see if these treatments are actually different from each other, if we end up with letters that they have the same letter or they share a letter, then that means that these two values are not statistically different from each other. These two are, because they don't share a letter. These two are not statistically different because they both share a C. So you'll see that as we go through. All right, so that was so this is the end of the clover, the green manure phase of the trial. So this is the fall of 2018, right before we would have terminated by doing some shallow plowing. And you can see, like, this is a 1-year alfalfa. So it had been in barley. You can see the barley stubble because we just harvested that off. Whereas over here, sorry, I'm pointing, but you can't see it. So on the left is the 1-year alfalfa. On the far right, next to that, right beyond that yellow flag on the far right, you can see really tall green manure, and that is 2-year alfalfa, actually. So you can see that we, have some differences among the green manures. And right before we terminated them, we took biomass production, and this shows biomass divided into roots and shoots. And I'm just going to orient you. At the bottom is the 1st-year green manure. So that was only planted with barley in 2018. On the top are the 2-year green manures they planted with barley in 2017. And again, this is at the fall of 2018. So for a 1-year green manure, red clover, medium red clover, it looks like the obvious choice, right? I mean, far and above in terms of biomass production. When you keep these for another year, then it becomes a little, some of the other, the mammoth red clover and alfalfa catch up with the medium red clover. And then when we look at nitrogen production, we see a similar pattern. Medium red clover, way out there. But when you have it for 2 years, again, the mammoth and alfalfa produced as much nitrogen. Again, that's roots and shoots. I mean, whether the roots is all of the roots is a bit of a question, but this is a good estimate, I think. Okay, and so then the next year we planted it into winter wheat, spring wheat, and then this is results from those plots, from the wheat yield, which is on the left, and then the grain protein from that wheat. Again, on the bottom, the green bars are the wheat following 1 year of green manure, and the blue on the top are wheat following 2 years of green manure. And the thing that really struck me was that those patterns we saw in biomass and nitrogen are not reflected here in wheat yield and grain protein. In fact, let's see if I can get this. Yeah. So in our first year, our 1 year green manures, there really were no differences among the medium red clover, mammoth red clover, and New Zealand white clover in terms of yield or in terms of protein values. So, and then when we look at the 2 year green manures, actually, medium red clover wasn't even among the highest. And alfalfa, which had been sort of a, laggard in some ways, caught up. So I think, this is 1 year of data, but, and we repeated this. COVID kind of got in the way of the wheat phase of the trial, but so I present this with some caution, but I think the overall take home is that there are alternatives to medium red clover, and and that we could have some pretty interesting nitrogen dynamics going on here that might make those alternatives better options in some cases. All right, so that's the green manure talk. We can stop and take some questions at this point. Or I can jump into the next, which.
Yeah, let's pause for questions. Maybe did folks in person want to go first?
What was that, Dave?
Very bottom of the slide, green is 1 year and blue is 3 years.
So the question was, and the bottom of the screen, oh, I guess we can't see the bottom here for some reason. Is the green 3 years and the, what is the difference?
The green is wheat that followed a green manure just for 1 year. So that wheat, those plots, the year prior, this would have been 2019, the year prior in 2018, it would have been barley undersown with those green manures. And so they only grew from when, you know, barley was harvested to the end of the fall when we terminated them. Does that answer the question? And then the top bars are ones that were planted in 2017. So they grew for that, the fall of 2017, and then the whole year of 2018. We did do some clipping and removed, like we simulated forage removal, but.
Ellen, I think what he was asking is the very bottom of the screen where you have the explanation of the blue and the green. We can't read what they, I think, well, maybe that's what you just gave us. Okay.
Yeah.
Good.
So I wonder why you can't see that. That's a problem.
We got a toolbar here from the video.
Oh, okay. So it's not on my end. Okay.
Yeah, we can see it online.
Okay.
We can see half of it online.
Do you have any guesses as to why the alfalfa didn't do so well?
Well, I think alfalfa, let me go back to, see if I can go back. You know, it's just a slower grower, right? So it's it just didn't, it really grew well in the second year, and it just doesn't put on as much biomass in that first year. You see that there. I guess it's actually easier, even though it's not biomass. I'm going to look at the nitrogen because it really, the pattern was the same, and it's just easier to see the bars. You can see it was, you know, it's just, I don't think it's worth using as a green manure for just 1 year. But if you're going to have a second year of it, you know, before going into your cash crop, it put on a lot of biomass and nitrogen, and then if you look at the wheat yield and grain protein, it was up there for equal with the others that did really well. So, okay. Well, maybe I should...
Let me just pause for a sec. Are there any questions from the online folks? You can either type them into the chat or unmute yourself.
I have one question. Yeah, thanks for sharing the data, Ellen. This is Chris Pelzer. And what I've been thinking about lately is like sweet clover, frost eating sweet clovers into small grains, like yellow blossom sweet clover. First, I was wondering if you have much experience with sweet clover in Maine, and then second, if there was a particular reason that maybe you didn't include sweet clover or looked at sweet clover in this experiment.
Yeah, no, that's a great question. Well, so we did a screening trial. I'm trying to remember if we included sweet clover. It does have a reputation for getting super tall and unwieldy if you let it grow. But I don't know how it would do in the 1 year system or the 2 year. I think that growth. Yeah, anyway, I'm not sure.
Thank you.
Sure. Do you have any experience with it? Have you guys used it as an interseeding?
Interseeding, yes, like in corn, and we've had good luck. No, nothing. Yeah, I have no personal experience like in a small grain. Just actually yesterday doing some reading about it. Just some different farmers commenting on using it, and it is a biennial. So from my understanding, there's not a lot of growth in that first year when it's undersown in the small grain. But yeah, then that second year, like you mentioned, it can get quite tall, and it's somewhat a pretty plant in terms of how large it gets, and it has a nice deep taproot. But yeah, no personal firsthand experience using it in a winter small grain.
Okay. Well, what do you think, Brian? Should I move on?
Yeah, sounds good. Thanks, Ellen.
Sure. All right, so the second topic is winter survival. I changed it. Originally, I called it winter kill, but I decided to be a little more positive. And as you can see, this is often, or in Maine, we sometimes come out to a field in the spring, and this is what we see. And it's like a glass half full or glass half empty type of thing. It's a hard decision whether to keep a field like this. This is a winter rye and significant winter kill here. And we are, the winter grains are have so many benefits, especially for organic growers. They're really good when you want to interseed green manures because they're pretty competitive, so you don't have that issue as much with the potential for the green manure to grow too tall. They're incredibly competitive with weeds. They, mix up your rotation in terms of fall seeded and spring seeded crops. If you don't have a situation like this and they survive really well, you're golden. You don't have to do anything in the spring there, so it relieves spring workload. And in general, they tend to yield higher. But our growers have just been struggling with this winter kill issue or winter survival. We're getting warmer falls, we're getting less reliable snow cover. And in fact, today it's raining. And we have saturated soils that like in a few days are gonna freeze up. And so it's been challenging. And a lot of growers are reluctant to actually plant winter grains because of the issue. Sometimes there's just nothing that you can do about it. So this is an example of a winter spelt trial we did in 2013. And, this is February. This is the date's wrong there on the left. That should be February 20th, 2013. But, and then in the spring, you can see where that ice, that we had a winter thaw, and then it iced up and we had a nice little skating rink out there. And where that ice built up, it basically suffocated the plants and they died. So that's a problem. And there's not much you can do about it except try to avoid fields where you have this kind of ponding, all right? Or we have been known to try to do something about it. This is Brian's co-graduate student, Aaron, who was desperate for this trial to work, but it actually didn't. We couldn't save the plants. So sometimes you just can't do anything. But then sometimes there are things that we could do that could help us. So this is another trial we had, a variety trial with winter wheat, and most of the varieties did really well, but two varieties suffered winter kill, and one was because of a seed source issue. It was just poor seed. But then in another case, the variety itself had really great establishment in the fall, great growth, but just didn't overwinter as well as the others. So, breeders have worked hard to increase frost tolerance and tolerance to snow mold. And so you can select varieties that are more winter tolerant. And then in that case that I showed originally of the winter rye, in that case, that was actually a seeding issue, a seed depth. issue. So when I pulled up plants from this field, you can see that they were all over the place in terms of how developed they were in early spring, which really would reflect how they went into the winter, the prior fall. And we were able to see where seed depth was. Like here would have been the seed. On this one, here was the seed way down. On this one, it's sort of like a Goldilocks thing, you know, not deep enough, too deep, just right. And this resulted from an uneven seed bed preparation, and then it just was a really dry fall. So it just turned out that seeding depth ended up being really important. So to try to figure out like when we can do something and when we can't, Heather Darby at UVM and I started this winter survival screening or survey. And so we are basically just going out to lots of winter grain fields and trying to follow what's happening to see if we can identify why we have winter kill. And then if there are management components or influences, then we could try to address that through management. So we have a bunch of locations. We're looking at site characteristics. We're looking at management factors. We're looking then, of course, at weather and the winter conditions. The farmers are tracking what's going on in the fields for us. And then in the spring, we come and we look at crop performance. And last year, so we did it the winter of, well, 2021, and then now this winter as well. Last spring when we went out there, the theme of the winter was pink snow mold. I mean, this is a winter rye field in northern Maine, and I'd never seen anything quite as dramatic as this. Pink snow mold is caused by a fungus that really thrives under cool, damp conditions. And we had probably the worst conditions possible for snow mold last year. They got snow cover on ground that wasn't frozen. And they had really good snow cover. I mean, that would have been great, but it just creates really humid conditions under in the canopy. When we brush back that dead mat on top, you could see that there are individual plants that were alive and actually looked pretty good. You really, generally speaking, you want to have a really well-developed crown that has 4 to 5 leaves and at least 1 to 2 tillers when you're going into the fall for best overwinter survival. And they had that. But I think the issue here was that the seeding rate was super high. This farmer had tried a new seeding method and was like at least 50% higher than what they expected. It was just a super dense canopy. They had seeded early, big, huge, lush growth, and super susceptible. Right next door, he had a wheat field that was drilled instead of broadcast and at a more reasonable seeding rate. And while it did have some snow mold, it really wasn't affected as much. I will say, though, that the rye field surprisingly did recover from that snow mold and yielded like 1.5 tons per acre. So I don't think it was affected. I mean, who knows what the potential was? We tried to document that, but that didn't work so well. But anyway, so snow mold. Another field we saw this pattern, and this was really striking in how uniform this patchiness was. Again, it's snow mold. We weren't quite sure if snow mold was the first disease that came in, or if it was infecting plants that were susceptible for another reason. A plant pathologist thought it looked pretty typical to see these patches where you might have one plant that's infected and then that spreads to the neighbors. But that this uniformity of that patchiness was unusual. And it was a no-till field. In some cases, we saw it in association with residue and thought maybe there was a seeding issue there, but it wasn't always the case. And we ended up wondering if it weren't seed-borne, that seed-borne issue. So now we started testing all of the seed that people are planting to see if we, and seed coming off of these fields, to see if we can actually detect snow mold on seed and if that could be a possible vector. Well, so let's say, you know, like maybe we can increase winter survival with this effort, but there will always be times when you end up with this, and it's a question about, well, what do? Do you keep this field? Do you not? Do you try to do something to help it? Whether to keep the crop, you would want to look to see, well, you know, what portion of it is viable? How even is it? Is it really patchy? You know, what's the size of the bare spots? Some people recommend, if you've got significant bare spots where you might be concerned about weed growth, that you could overseed clover at this point to try to just cover those areas. I wouldn't recommend, some people have, you know, asked about putting, you know, maybe putting out some other small grain, and I think that just creates a mess of different crops maturing at different times, and so I wouldn't recommend that. In general, there's some guidelines in terms of deciding whether to keep a crop or not. If you've got 20 to 30 plants per square foot, they say, yeah, that's great. 12 to 15 is like, yeah, that should be enough, but you might consider top dressing to increase the tillering of the plants that are there. Less than 12 plants per square foot is generally recommended, that consider replanting recommended. And then if you're trying to decide whether to top dress or not, there are some other guidelines. So that would be based on the tiller count. So not the plants, but now looking at the tillers. And when we talk about tillers, we're talking about any shoot that could produce a seed head. So the main shoot and any tillers. And so if that number is low, and I'll show something what might be considered low, then you would try to top dress early in the spring to increase the tiller numbers and spikes. And if it's high, but you still wanted to top dress, you would delay it so that you're not stimulating too many tillers, and that you're using that nitrogen. Let's say it's a winter wheat, you want to boost protein levels, you would put that nitrogen on later. And we did some work early on with using organic end sources, like a dehydrated chicken manure, and it was effective at increasing tillering and increasing grain protein. So there's been a lot of work on this approach, adaptive management approach, in the Southeast and some other areas. We haven't had it as much. We haven't done as much in the Northeast, but this is just an example of, like, you would look at your tiller density, what it was, and then to estimate how much nitrogen you would put on. So this is from Virginia for winter wheat, a conventional situation. They're saying like 65 tillers per square foot. Oh, I should put on about 50 units of N. So the question we had was, you know, could we use it for organic, and could we use it in the Northeast? And we did some trials on the research station and on farm, and the answer was, yeah, absolutely. So I'm going to just show you two examples from an on-farm site that illustrate kind of why you might choose to top dress or not top dress, I guess, in that situation. So this is a site that had low tiller density, relatively low tiller density, and we put on different rates of nitrogen, and then this is the spike count. So it's so the tiller density is the number of tillers early in the spring. The spikes are the actual number of seed heads that were produced. And so in this case, this red line shows you the tiller number. And so if we didn't put any nitrogen on, the tiller number and the spike number were really similar. But by putting on nitrogen, we were able to stimulate more tillering. And in the end, we got more spikes. And that actually translated into an increase in yield. But it sort of, you wouldn't have to go more than 60 units here. This was, I will say, for this trial, the nitrogen source was non-organic. And finding an organic source where you could put on that much might be challenging, but the concept is similar, I think. The other case I wanted to show you, though, is where we started out in the early spring with a higher tiller density, 65 tillers per square foot. So that's this bar, that's the tiller number, and then our spike count. And in this case, we saw increasing spikes with our nitrogen applications. But, it was more about preserving the spikes that were there than about increasing tillering. So more of the tillers, with more nitrogen, more of the tillers developed into productive spikes, I think is what the point is. But what happened is, in terms of grain yield, there was no difference. And that's because as we got up higher, we ended up increasing lodging, and it was a problem. And so in this case, you don't really, at a high tiller density, you don't necessarily want to put on nitrogen. You don't want to, you can have too many tillers. It could cause problems. So this would be a situation where you would wait until later in the spring to put on any nitrogen if you were trying to increase grain protein levels. All right, all of these end on a data slide. I don't know if that's very stimulating for a discussion, but but this one, that's the end of that section. If anybody has any questions, glad to, or comments.
What was your situation with Dawn and fungus infection for trying to sell these grains?
Oh, they didn't have well, we weren't actually, okay, let me back up. This is winter rye. We did it with winter wheat. Those years oftentimes we don't have issues, so many issues with Dawn and winter wheat in Maine. I mean, we have had times, but most of the problems we've had with Fusarium head blight have been in our spring grains. And I think it has to do with the timing of flowering and the inoculum levels building up. But it's a good point in this, any diseases, just as we had an issue with lodging, I don't know about Fusarium so much, but you could, by also just increasing tiller densities too high, then you set yourself up for other disease issues. I have saved the very best for last. Well, since Brian asked me to do this talk, I saved the weed section for him. So
Thank you.
I can launch into that if you want.
We have one more question in person. Rodney?
Yes. Your research there in Maine, what growing zone is that in?
Oh, that's a good question. We're like 4 and 5.
Other question, do you have any reservations planting wheat after barley?
Yes, I think you can get away with it here and there, depending on the length of your rotation and what else is going on. But generally, it's discouraged to do small grain on small grain, definitely.
What variety of spring wheat was that?
Well, we've often used Glen. So for the trial, the green manure trial was probably Glen. Yeah. All right, well, given time, I'm going to launch into the weeds, the weed section. So I'm married to a weed scientist, and and I cede that territory to him usually, and I work more on fertility. And so I am reluctant to admit that weeds are the #1 issue, most important issue. But I think they are. I mean, at least for our growers, that is what they've struggled with the most. Our organic growers have, especially in spring grains. This is a spring, I think it's, I don't remember if it was a barley or wheat, but it's a spring grain field, and you would think it was a canola field or something. So the weed pressure can be overwhelming. And I say in the collective we, there's been folks like Brian and other students of Eric Gallant's who have worked on different aspects of weed management. The tine weeding is what most growers in Maine at least have as a tool to control weeds in organic small grains. And if the timing is right, you can really get great control. But the timing of you need to hit those weeds when they're really tiny in that white thread stage, so you can almost barely see them. And whether that coincides with when the wheat or the oats or barley or whatever are big enough to withstand the tine harrowing, that's the critical thing. And we find that weeds like wild mustard and wild radish tend to be pretty well rooted by the time we feel like we can go in with a tine weeder in our spring grains. And so Eric started looking at some other methods. When we were in Denmark, we saw this inter-row hoeing system. People widened the rows of the small grains, treated it more like a row crop, and cultivated. He got a Schmatzer inter-row cultivator. That was a steerable thing for research purposes. People it was hard to convince people that that was a good option when you see a researcher sitting on the back steering something, but they do have field scale options. Then we went and started looking at a camera guided system using that same cultivator, but put it on a side shift unit that was robotically controlled. There's a camera that you mount. It tracks the rows through a computer up in the cab of the tractor, and then it adjusts the rows back and forth to precision guide the cultivator. And it takes a ton of adjustment, but you can, if you get it adjusted right, you can go into standard row spacing and have really great or cultivation between the rows. And so we did a lot of work with on farms demonstrating this. This was just another farm field where we were working with it. And we, still, we kind of had people going, well, yeah, that's kind of a little cultivator. So we got some funding from the Northeastern IPM Center to get a bigger cultivator and demonstrate this on farm. And I don't know if you can see Brian is way over there on the right at this field day. So that's all well and good. And I know that there are some growers in New York using these camera guided systems, and it's awesome. When it works, it's great. They do a really good job of getting those weeds between the rows. But then sometimes this is a field where we ran the cultivator, and you can see sort of in the foreground that if you've got a weed in the row, it's hard to control that. And Brian probably has some great suggestions of other tools that might be able to address that. But we find that this kind of just puts us back at where we started with high weed pressure. So we end up with those weeds in the row going to seed, and the seed bank remains high, and that background pressure remains high. So then we heard about this tool called the comb cut, a weed clipper. I mean, or weed clipping isn't so much just about this tool. I mean, people talk about swathing fields up above the canopy of the crop to cut off weed seed. So the goal with this project was to see if maybe we could reduce weed seed production so that we can at least start moving in the right direction with our weed management and start reducing that weed seed bank. And so this comb cut was designed in Europe. It can go, because of its design, it has these like overlapping knives that are sort of angled, and floppy parts of the plant can move through there and not get cut off, but stiff-stemmed weeds would get cut off. If you're interested, you can watch all sorts of videos. I don't think I'll show that right now, but there's tons of videos online and it's pretty impressive. I mean, this one, you can see what's behind the tractor and what's in front, and they've clipped off a lot of those blossoms. We had to simulate a comb cut or weed clipping by using scissors, basically. So we had our research technicians and us all out clipping because we wanted to just look at the potential. We didn't have enough money to buy a comb cut, and we thought, well, maybe the timing of the mustard and the small grain crop, maybe it actually, we just wanted to look at, does it have potential to actually impact weed seed production based on that? So we set up this trial, and we had different strips and also included cultivation and tine harrowing and clipping at 2 different dates. And here is our data. So the top is the percent of mustard weed plants remaining. So when we put this trial out, we planted the wheat, and then we also planted a condiment mustard as a surrogate weed. So we planted this mustard, and we had some plots that only received tine harrow, some that were selective cutting, like as if a comb cut went through, some that were cultivated, some that had cultivation and tine harrowing, and some that had all 3. We did not have a very good year for effectiveness of the tine harrow. You can see it only reduced the number of mustard plants by a little over 20%. And selective cutting, well, actually, now that you look at it, that was only selective cutting. So I think we had sort of some natural loss of the mustard. The tine harrowing didn't do anything. So, but our cultivation did reduce number of mustard plants. Didn't really get that much more of a boost of combining, which actually is not, is sort of in contrast to a lot of other work that's been done. And then combining all 3 also didn't. So really the most effect that we got here was from cultivation in terms of reducing the number of weed plants. But when we looked at the end of season mustard weed biomass, we did see some effects of the selective cutting here. And this is where it's targeted. So the green bar, part of the bar, is the non-reproductive part, all the stems and leaves. But the golden part is the seed pods. So we took the biomass and we separated them to those 2. And you can see that like cultivation reduced the total biomass, but selective cutting was what really reduced the reproductive biomass. And then if you put cultivation and selective cutting together, that also, well, those 2 are the same. Anyway, point being that this clipping really did reduce the reproductive biomass and has great potential as a way to reduce that weed seed production and future weed pressure. There are some people who have done work on the comb cut and weed clipping in general in Canada, and they've used a real comb cut and some other swathing things. And they looked at in lentils and in wheat. In lentils, they're not actually using, they weren't using the comb cut. It would just destroy the lentils. But above canopy clipping, reduced mustard seed set by 60 to 90%. And I think that the higher end was where when they clipped more than one time, and later clipping was more effective than earlier. No effect on yields at all. When they did use the comb cut to clip in the canopy, again, that can go down a little bit into the leaves, they saw mustard seed set reduced by about 50%. But it's one of the things is that this comb cut device is there's a couple ways you can set it, and you can have crop damage if it goes a little bit too low, or if you're not set, the angles and stuff aren't quite set right. So that's just something to keep in mind. But I think it could be another tool in the Many Little Hammers toolbox for weed management. All right, with that, I'll take any other questions or comments, or has anybody used a comb cut, I guess?
That's pretty cool, Ellen. I haven't seen a comb cut in New York. But yeah, certainly, I think we have a lot of folks that will do some above canopy mowing in certain situations, more common in vegetables maybe. But yeah, to try to reduce the seed set, it's kind of a similar idea.
Looks like you have to have a very uniform stand to deal with it.
You mean in terms of height? We did have the comb cut person, a rep, contact us, and we were hoping to get one out in the Northeast to demo, but COVID interrupted that whole communication. But if there's interest, that might be a possibility, I guess. I will say we have an issue in Maine, just for ourselves, that we don't have a critical mass of organic grain growers to attract some of those manufacturers to come demo things, spend the time to come do it. But maybe one of the things I've liked about collaborating with folks at Cornell and Vermont is like if we as a region work together, I think we do have a critical mass that makes it interesting to manufacturers.
Any other questions for Ellen from either in person or folks online?
I have a question. Have you done any studies looking at crop density, also row spacing, such as the narrow row spacing used in Europe, and how that affects weed density?
So I couldn't hear that question very well. There's something about crop density, is that right?
The question was regarding the plant density and weed production. One, looking at just the seeding rates, and secondly, also looking at row spacing, going to narrow rows such as Europe has done with the 125 millimeter.
Yeah, so in small grains, they, you know, your number one weed, well, there's a lot of, there are a lot of, what's the word? It's not methods, but anyway, there are a lot of things to do to set up for giving you the best weed competition. But cereals themselves are very, very competitive, and their competition with the weed is probably one of your biggest tools to use. And so getting that seeding rate high is important. And they say, you know, about 50% above conventional seeding rates for organic systems will help keep weed pressure or reduce or increase your crop's competitive ability with the weeds, I think is the way to say it. And people have done looked at different seeding arrangements to try to achieve that higher density. There's some people who swear by cross seeding, you know, seeding in two different directions. I know Eric tried some things where he broadcasts seed at the same time as drilling to try to get that more uniform density. I just saw a talk by Steve Shurtleff, though, that really said that, and he's in Saskatchewan, that it wasn't so much the spacing, the uniform spacing, as the actual just having a higher density out there. So in normal row spacing, you know, 7-inch or something, that was, they didn't get as much, or you know, it's expensive to go to even narrower rows or try to figure out a way to do it. And they didn't get as much bang for their buck doing that as they did by just increasing seeding rate. And so, yeah, does that answer that question?
Yeah, I think so. I have another question. Have you looked at any trials where you're using both a rotary out and a time reader simultaneously for reading small grains?
So using I'm sorry, something and a time leader simultaneously.
A hoe and a time reader.
Oh, a hoe and a time leader. Well, so that we haven't done it in as much in small grains. Eric and Brian have done it in vegetables and in corn, and it really, you know, it's like the 1-2 punch of you're digging up, and there might be some plants, some weeds that still, you know, could recover from the hoe. Their roots are in there, but if you come by with a time leader after, the theory is, and it's worked in practice, that then you're disturbing those roots even more. And we didn't see that in that one trial that I showed you. But like I said, that was really not indicative of like all the other results that have come off of that research farm in other types of crops. Oh, and even in barley, I think, didn't Margaret do some of that in barley as well?
Yeah, I think so. Yep.
Yeah, so I think our result was, I think if you can combine them, that's the right way to go, really. Definitely.
Do you find that increasing seeding rate affects the tillering? So either one's detrimental to one or the other, tillering versus a big cover?
Well, so there's two different strategies on that. So if you're, you know, the tillering, I would say for a winter grain is really important, and it's a key part of achieving, you know, your spike density and at the end of the season. For spring grains, there's often Europeans especially have gone more to the strategy of just putting the seed out there. So you've got like a target of 1 spike per plant, because there's not a lot of time for that tillering to happen, not as much as in a winter grain. So and you know, whether it is 1 spike per plant or you know, 1.5 or 2 spikes for, you know, I think trying to go with a much higher seeding rate in spring grains is a proven strategy. I mean, the other thing to think about is that tillers mature a little bit later. So if you want more uniform maturity of all those spikes, then just going with a higher rate is the easier way to achieve that. So, but absolutely, tillering and the seeding rate are inversely related, definitely.
Great. We got a couple little things online here in the chat. Chris Peltzer shared a link. If folks are interested in person, maybe Faye can share that over lunch, to some work that Stefan Cordeau did evaluating the comb cut. So a little bit more information on that. And then we had a question about some of the makes and models of the cultivators that were used. Ellen, I know Eric used the Schmatzer, was kind of the smaller one, and then your larger one was a Cult Cress. But what about the wide row cultivator that you saw in Europe?
Oh, I wouldn't know. I don't remember what that one was.
Was that the System Chameleon?
Well, okay, no, the one I showed was not, but the System Chameleon was one that Eric and some farmers went to look at, in particular in Sweden, and that one's pretty cool because it goes from a seeder to a cultivator. Everything is indexed right on, you know, like you're all lined up. There's none of this adjusting individual shanks and things to try to line up with your planter. But the other one, I don't remember what the red one was. I don't know. And then we used a Garford camera guidance system. There was a lot of debate about whether it should be like a GPS guided or camera guided, but folks kind of felt that for that level of precision, that and you end up with sort of some drag and things that they wanted to have a camera really like right at the point where you're cultivating to help guide through the crop instead of trying to rely on GPS.
Great. Well, all right. I think we're coming to the end of Ellen's time here. So thanks so much, Ellen. And if you're able to stay on, and if there's any other questions folks want to enter in the chat, that would be great. But yeah, let's give Ellen a big hand, and thanks for joining us today.
All right. Well, thanks for having me. It was really fun, and I hope you guys have a great rest of your meeting. So I'll stay on for a little bit. Okay. Thanks.
So I guess, Sarah, you're gonna go now. There's the King's Agri-Seed. I'm gonna talk about some of the opportunities in hemp.
Thanks, Lou.
So you're seeing our screen now, Brian?
Yes.
Okay, great. Yeah, thanks. They're just gonna turn the lights off here in the room. So I have to say, this is a first for me, presenting both virtually and in person. So Brian, I'm going to ask you to interrupt me if there are questions in the meanwhile. All right. So
Okay, I can do that. And if you can put your presentation into presenter mode so it takes up the full screen, that would be great. Or present slideshow.
we have done that. So what do you see?
Sure.
Yep. I think he's seeing it, but he saw the tiles on the side.
We are sharing the screen, Brian, and we'll try to do.
If you go up to slideshow, it should be the first option down.
getting a picture of me struggling with this presentation. All right, I'm sorry, you said presentation. Part of it is that Chase got this weird joystick on his computer, and I am not familiar with that. All right, now, is that full screen for you? Brian? Because I did.
That's that is presenter mode, I think, which is what I said, but I guess I meant full screen mode.
Brian, we were only seeing 3/4 of the slideshow here because of the tiles. That's not what you're seeing now?
No, we see presenter mode, so we see the next slide. Is there a way you can go full screen with just the slide that you want to show?
It's showing on our computer, but our LCD projector is showing it just a single.
Okay, if you can exit out of this, click the X on the right and then go up to slideshow at the top. You see the tab right above your mouse there?
We're getting there.
I really feel inept here. I do not play video games with a joystick, so I guess. Ask me to play piano, I'm on that, but not in this joystick. So, present from the beginning, is that correct?
Yeah, let's try that.
Turn off presenter view.
Okay, yep, good idea.
This is painful for me too, everybody. All right, now what do you see, Brian?
It's still working on it. It hasn't changed yet, but maybe it's just being delayed. We're still seeing all of the slides on the left-hand bar. Did you click from beginning? Yeah, try that one.
Try this one now. This is the one I usually use. All right, I hit the click from beginning.
It's showing full screen on the projection, but not on the computer.
I know, there's a swap, somewhere there's a swap view. Let's see. Brian, I'm at a loss. I don't know what to tell you.
So do you know how to, so it's, you need the two screens to be duplicated, not different.
It's not duplicate, is that what you're saying?
It's not,
You changed that this morning, Faye?
Right, but I changed it to duplicate, it's not extended.
I'm gonna try,
It's not duplicated,
just
no.
check that again. It's not duplicated now.
You know, how do you get,
F8 is change the screen.
We're working this out. I just want to let everybody know online that I actually have some hemp products that I'm sorry that you're missing. I have some hemp products from around the region on display, things that are manufactured right here in New York and Pennsylvania. And of course, I have literature here. And at the end of the presentation, if anybody wants to connect with me either by phone or by email, just let me know. I would really enjoy talking with all of you.
Great, thank you, Sarah. Oh, it's fixed. It looks good now.
Good job.
All right, let's hope the rest of the presentation goes smoothly. Well, like I said, this is the advantage of having a hybrid meeting is that there are people online and the people here in person. So I need the feedback from the audience. I really rely on that. So, okay. So what we're going to talk about today is we're going to talk about what's happening in the industry. a little bit on the agronomics and why King's AgriSeeds is involved with hemp at all. And I'm going to start here with a bit of statistics.
You're
And
probably
two-
gonna need to stay close to that.
I'm sorry, what did you say?
You're probably gonna need to stand close to the speaker so they can hear you.
Can you hear me okay, Brian?
Yeah, it's best when you're right next to the microphone.
Blocking people from viewing, so I guess you'll.
They can move, they can move, stand right up.
All right, so in just a little history here, in 2019, we had really big dreams. We had planted about, or had permitted about 500,000 acres across the United States. Most of those acres were permitted for CBD production. And about only 50% were planted, and only about 67% of those acres were actually harvested. Yeah, that's mostly CBD. In 2020, the permits were cheaper, and these again are mostly CBD acres, down a little bit, 465,000 across the United States. But what you can see by the planted acreage is that hesitancy is already setting in. Only about 15% of the permitted acres were actually planted. And of that, 50% are harvested. And I'm pointing to the 2020 bars right here. In 2021, revenue from corn and soybeans was really promising, and that meant the simply curious people didn't plant, and the smart people also didn't plant. So the right thing to do was to go for pretty much sure revenue. However, the dedicated people are still in it with planting almost a higher percentage than they were the year before, 200,000 acres with 40,000 planted. And of that, 60% of the acreage is actually harvesting. So at this point, primarily it's CBD acreage, but grain and fiber hemp are on increase. And in 2022, we will begin tracking grain and fiber separate from CBD. We don't know the acreage in from 2019 to 2021 that were separated by CBD and industrial hemp. So are we poised for growth? Here's what we need. We need clear federal and state regulations so that we all have guidelines. We'd like to subtract the grain and fiber from all of the testing that needs to be done, because for the most part, our grain and fiber varieties are very, very low in THC, which is the cannabinoid of concern. We need more sales of hemp products, and that's why I brought some samples with me so that you could see what's really happening. And we need more local processors and manufacturers, and that is also happening. We're in the early stages of that. And we need good harvesting equipment, primarily for grain and fiber, but also for CBD. The mechanization is very, very important. And what we are all working on at the university level and at King's AgriSeeds is the best cultural practices for growing hemp. On our research farm, we have about 40-acre research farm where we do trials, and we've tested both grain and fiber varieties as well as CBD varieties for direct seeding into the ground, as well as for CBD, some transplanting. So here's some encouragement for our region. We have 14 different processors or people who are involved with hemp that are already in motion. And that's 14 more people than we had 3 years ago. We have people who are working on food products like hemp hearts and hemp snacks, hemp seed oil, building materials, fabrics, paper, soilless mixes for the greenhouse industry, and just recently a special release for chicken feed. And that is in Pennsylvania, and it's restricted to one company. I'll talk about that in a little while. In Pennsylvania, these are the 9 companies. Pretty exciting. Ole Hemp is in Berks County, just north of Lancaster, and this company is producing pet bedding and kitty litter from their grain and fiber varieties. And I have a bag of chicken litter. This company, Ole Hemp, is actually selling their chicken litter for about $87 a bag. And of course, this is not for commercial chicken producers. This is for retail. Things like tropical birds or specialty type situations, but they are selling. This is Tuscarora Mills. I have some fabrics there, blouse weight all the way to denim weight. And Tuscarora Mills is in Bedford, Pennsylvania, and they are selling their 100% hemp fabric. This is Biofill Fibers. When we talk about processing, we talk about decortication. Decortication is the process of removing the inner core or the hurd, H-U-R-D, from the bast fiber, the fiber on the outside, like a bark of a tree. So decortication is taking the core out. And this is actually the finest process that I've seen, and it's right in Eastern Pennsylvania. And I have samples of their beautiful cotton fiber at the table, and also pictures later on in the presentation. This is the beginning of construction. Hempcrete is a big deal in Europe right now, and it's moving to the United States. This is a company in Eastern Pennsylvania, Marichon, and they are importing, unfortunately, their hemp products from France because they can't get the specifications that they need right here in the United States. Last year, they imported 105 tons of hemp hurd, and if you pick up that bag of chicken litter over there, it weighs nothing. So 105 tons of hemp hurd is many containers, and that should be grown right here in New York and Pennsylvania. Natural Textile Solutions, this is an existing fabric manufacturing company based in both India and also in Europe. They have the hemp spinning process down, and they will be importing their equipment to Western Pennsylvania in order to put up a plant, hopefully in 2022, so we could potentially be delivering raw fiber to them at the end of this season. Don Service is a company that is really building the community around hemp. And I think that that is the energy that is around hemp. It's about the community. At this point, farmers are working together with breeders as well as with the final end product users. There's a big community. It's beginning to be very tight, coming from that 500,000 acres down to a much smaller cohort of people who are collaborating in order to launch this industry. It's a pretty passionate group of people, and Don Services is one that's combining some humanitarian efforts, working with disabled people and veterans in order to build affordable housing with natural materials that are sourced right in the region. This is in Newcastle, Pennsylvania. So some of these companies are still in the R&D mode. Susquehanna Mills in northern Pennsylvania, they produce oil. They not only hemp seed oil, but also sunflower and canola oil. Well, their sunflower process is solid. They have good sales for that, and they have currently shelved the hemp seed oil. But they're poised and ready to jump into it when the market breaks open, and that's kind of where we're all at. If you were here for lunch today, I have some Kreider Farms Chickies Creek hemp eggs, and they are fed with a portion, the laying hens are fed with a portion of their diet in hemp grain. And we have deviled eggs here in the back, so you'll be able to taste whether or not you think the hemp eggs taste any different. But they are higher in omega-3 than standard eggs, and of course that is the big claim for hemp grain altogether. It's a really great source of protein and omegas. You just can't go, though I want to caution you, just can't go ahead and feed your chickens hemp. Kreider worked very hard for 2 years to get a special permit from the USDA in order to make this particular product. So they worked very hard. These are organic eggs, and they deserve to have the lead on this because of all their work. Here in New York, I know of 5 companies, and certainly there are more spanning the state, really. Eaton Hemp is in Eaton, New York, and I happen to eat Eaton hemp hearts every day for breakfast on my yogurt. I love them. They taste good. They make me feel better, and I'm not hungry by the time 12 o'clock rolls around. That high protein is a slow burn and keeps me going throughout the morning. And I also believe in supporting the home team. So get your hemp hearts locally. Cottrell Paper is a 5th generation paper company that is in Rock Springs, New York. They are manufacturing 100% paper and cardboard products, all the way from stationery to boxes. Primarily their boxing is going for the hemp industry, CBD packaging and whatnot. But they have, I understand that when I visited there, they had just landed a contract to produce the little cards that go on the jewelry. They are manufacturing that product for some big box manufacturing or company elsewhere. So 5th generation paper company looking at already producing hemp paper and up to 5/8 inch of cardboard. Buffalo Botanicals, they are in the grain end of the market, and they are working towards hemp protein powder, also hemp seed oil, and they have a line of bird seed for tropical birds, especially birds. Others right here in central New York, Greg Brown, New York Carbon Mining in Romulus, they are ready to go with a really great facility down in the Seneca, former Seneca Army Depot. They have a big complex. Things are happening there. They are also in R&D mode, just about ready to get rolling here in 2022. Central New York hemp processing in New Woodstock, Stephen Halton. He's a farmer. He also is developing his own decortication equipment, and he is currently manufacturing plastics, straws and containers and silverware. So, and I have samples of these. So these are all happening right here. And just a couple of weeks ago, these 2 researchers at Rensselaer Polytechnic Institute, they have determined that rebar made from hemp is as strong as steel. And this is very good news for the building and construction field, because now we can have renewable resources that are part of our building code. The demand for grain is good. In 2019, there was a surplus in Canada. Prices were low as a result in 2020. In 2021, we had a lot of drought and fires in the Midwest and the West. So that surplus was consumed. And in 2022, grain prices are higher. For conventional grain is at about 50 cents a pound. And for organic grain, $1.30 a pound. And a typical yield can vary between about 800 pounds per acre to 1,000, even to 1,400 pounds per acre on grain. So you can do the math of that for organic. Demand for fiber is also unfulfilled at this time, mainly because we don't have the decortication facilities. A lot of capital is needed to invest, and millions of dollars actually, to build these processing plants. Our farmers also have limited experience. We'll talk a little bit about cultivation in a little bit. And one of the biggest headaches is the harvesting equipment, both for grain and for fiber. The decortication begins with a harvest, and that is, I'm going to point here to slide number 1. This is a pretty short variety, a grain variety that is grown on King's Agri Seeds. That's Tim Fritz there in the background, showing it about a 5-foot level before we cut it down. You can harvest it with a sickle bar mower. In the bottom right, number 3, that is field retting, similar to what happens with a hay crop. You allow it to begin to soften and become less stiff. Against the decortication process is really a rotting, ROTT, as compared to retting, R-E-T-T-I-N-G. So retting is where the gums begin to soften, and then that long fiber up to 8 feet tall can be rolled into a bale, dried and then rolled into the bale with a round baler. Now here's the decortication process, and I do have samples of these on the table over there. This is number 1 is the stalk that's actually in the field. Number 2 is when it's harvested, and in this case it's been chopped. The back herd, or the herd, is number 3. That is the products that are used for chicken litter and kitty litter and bedding and that sort of thing. That's that inner woody core. Up on top, number 4 is the fiber. That's been separated from the outside, and that is what is further spun and degummed, and then it turns into number 5, that really soft cotton fiber, which can then be used for paper or for fabrics. So a little bit about King's Agri-Seeds and hemp. Tim Fritz, the owner of King's Agri-Seeds, really found a lot of benefits with CBD for his own personal use and decided that this would be a good product for farmers to grow, particularly if it's direct seeded. Also, he understands about the importance of new building products, and particularly the grain, the nutritional content, the low calories of the grain, hemp grain. And so we carry both CBD and grain and fiber varieties. About the agronomics, Ellen, it's really no different than anything else. Ellen Mallory started out, or mentioned in her presentation, 2 things. One is about field selection and the other is about weed control, both of which are just as important for hemp as it is for any kind of small grain. Research is going on all over the Northeast. Dr. Darby, who she mentioned, out of Vermont, Dr. Gilbert Jenkins, rather, here at SUNY Morrisville. Larry Smart's heading up the Cornell research program for hemp. Dr. Alyssa Collins at Penn State. We're all working on the best cultivation practices for hemp. So seed bed preparation and planting depth, all of that is important for emergence. Emergence is the toughest piece about hemp. Getting those little seedlings, they're very wimpy until they're about 6 inches tall, and then Katie bar the door, weeds simply cannot compete if your stand is good. A starter fertilizer is important, giving those little seedlings something to feed off of right from the beginning. And hemp has a pretty strong nitrogen demand at the beginning of the crop. It isn't throw it out there and see how it grows. It needs nurturing just like any other crop. The fiber timing for harvest is before it sets grain. That's when the fiber is at a maximum percentage of the stems. And that, of course, is the higher dollar value. Herd is the low end piece, but if you want herd, you allow those plant a little bit further apart so that you get a bigger core. Grain also enjoys a little bit wider spacing so those seed heads can fully develop. Grain is harvested, of course, at the end. And believe it or not, one of the key indications for when to harvest the grain is when the finches and the birds come to eat the hemp. So we talked a little bit about field retting for the fiber. The key with the grain, however, is because grain is a high oil content seed and it can go rancid pretty quickly. So condensation is a problem. Bringing that seed down very, very quickly within hours after harvest to an appropriate moisture level will keep the seed from going rancid. Then you can store it, but even in storage, because it's high oil, it's still very fragile. You'll just want to keep turning that grain while it's in your grain bin so that moisture doesn't develop in the bin. So these are the varieties that are our genetics people who we work with. All of them are here in the United States. We work with Hemp Genetics International and International Hemp for our grain and fiber varieties. And we have varieties that can span from about 4 feet tall to 13 feet tall, depending on the purpose of the grain and fiber. We work with Phylos Biosciences on our CBD varieties. and we carry 2 auto flowers. Those are hemp varieties that are not related. They are not triggered to flower by day length. They will flower much like it's a crop rotation, just like sweet corn. So you plant every 2 weeks, you can harvest every 2 weeks, and you'll have fresh CBD flower throughout the season. So I just wanted to introduce you to hemp. There is a lot of buzz about it. I believe we have hit the rock bottom for CBD pricing. We are on the increase in demand for grain and for fiber. And I wanted to talk with you about it so that you are aware that there are things happening right here in New York, in the Northeast, surrounding grain and fiber in particular, and that perhaps this is something that you might consider for your crop rotations. Are there any questions?
Yeah, one question I have, since I have one combine, what kind of cross-contamination is there between hemp seed and other grain crops that you may need to sow?
So I'm going to repeat the question. The question is with cleaning out your harvesting equipment, how important is it? Just like anything, it's very important for 2 reasons. One is about the gluten-free nature of things. So any grain that is labeled as gluten-free, I don't know a lot about this, but it's very important. Also, because grain and fiber hemp are so fibrous, they can get caught in the turning pieces in your combine, and that, truthfully, that's a fire hazard. So our breeder, he carries 4 fire extinguishers with him because the hemp can get caught up in all the gears, and you have to check frequently. It is not, like I said before, it's not plant it and see what happens. We have to get prepared for this. So the equipment piece is not my expertise, but I can tell you that I've talked with people. I noticed the sign up here in the building for SUPUP, the grain harvesting, the grain storage people. Visited with them at a trade show. The grain for hemp is smaller. I have some grain over at the table there. It's smaller than corn, of course, and it requires a finer screening. There's a lot of dirt with hemp, and that creates its own set of problems in the storage and also in the processing. So we need to learn more. Before you dive into this, I would suggest getting started slowly, but you can use existing equipment, but you have to know how to modify it.
Well, what I'm wondering about is, do you know of anybody that's been selling other crops that have been rejected? Some hemp residue. I mean, cleaning the combine out is
Did you say hemp
necessary.
residue? Like
Cleaning the
another?
combine is necessary, but it's impossible to get everything.
I don't know. I actually don't know of anybody. There frankly, because of the really particular demands of grain, I don't see a lot of grain harvested at this time. It's mostly for fiber. There's a big demand, of course, from retail for kitty litter and those low-end processes. That's sort of the easy, low-hanging fruit. So growers who are growing grain and fiber are kind of starting with that sale.
The difference in the seed size makes it pretty easy to clean it out.
So Rod said that the difference in grain size would make it pretty easy to clean out the equipment.
But, well, if you had some contamination of hemp in your small grain, it would be easy to screen to clean that hemp out.
Got it.
So if there was a contamination.
Another question I have is, because of the fibrous nature of the stuff, is it a nightmare to bail off around?
I know that you can't run at 10 miles an hour. So yes, you have to go slowly and you have to check periodically. I don't know how much that is. I think it really depends on how big your crop is, if it's 10 feet tall or if it's just a short 3-foot grain variety. I'm guessing the 3-footers are pretty easy to harvest. And your volume, of course, of fiber is not nearly as much as if you have a big fiber crop. All right, are there any questions, Ryan?
Yeah. Daniel Gladstone asks, both THC and CBD require pollen control. Do you anticipate conflict between interest groups?
So what Daniel's talking about is CBD is and THC cannabis production requires female plants. Grain, on the other hand, requires pollination. So are they in conflict? Absolutely. Do I have a solution to that? I think the solution will probably be in breeding, because I don't see, unless it's voluntary, farmers in one county adopting a CBD approach and farmers in the next county saying we're only going to grow grain here. I don't see that level of cooperation. So I think the answer to your question will be down the road, and I think it will be through breeding. CBD varieties, there's already some triploid varieties that are out there, and they are sterile flowers, so they don't accept any pollen. So that would probably be the answer, at least for the CBD side. I can't really speak to the THC side.
Great, thanks. I think that's all from us online for now, unless anyone else wants to unmute or put something into the chat for Sarah.
What fertilizers do you use to start the little plants?
Are you talking about in the green, like a greenhouse situation, or in the field?
In the field.
In the field, I'm going to turn that to Rod, because we grew our grain conventionally. We used a 2100 because we wanted a really fast start for those seedlings. And of course you need to have, hemp is a boron, has higher boron requirements. So always a soil test is important before you get started. But we wanted those seedlings to have a very good start. So having an upfront charge of nitrogen is very important.
I would say in very general terms, you're probably looking at similar kind of fertility as you go forward.
Yes. Corn is a good one. The key though is having rapid release. So when the nitrogen is supplied in an organic form, the soil temperature will be very important. And that is because the microorganisms that are breaking down that nitrogen into usable forms for plant need to be active. So where the conflict kind of comes in is with grain and with fiber in particular. Every day of growing adds to the height of the plant, and that adds to your yield. So if you have to wait, let's say you wanted to plant May 15th, but you know your soil biology isn't active at that point. If you choose to wait until June the 5th, when it's a little warmer, you will likely have better emergence and you will have better weed competition because your plants have a better chance of starting off really strongly. So those are some of every grower, every farmer has to weigh that, right? Every year, when do we plant? It's the same with hemp. There's no difference there.
You mentioned the need for quick nitrogen early on.
Yes.
So in an organic setting, that may mean the need to use some sodium nitrate, regardless of, manure, living covers.
Yes. And when you're planting into living cover, there are difficulties with that also, because that living cover competes again for nutrients. And so doing what's called strip till, you've heard of that, having that initial seed bed, whether it's a couple inches wide, really tilled up very finely, and using an aggressive coulter to get rid of that organic matter and make a nice friable seed bed for that seed, that's really important. Yes?
What kind of row width seed space?
So row width for grain and fiber is typically a grain drill, so 7 inches. Some farmers are growing at 15 inches if they're growing for that herd, that wider inner core. With CBD, for autoflowers, it's typically 15 inches to 30 inches. And then for photosensitive varieties, it can be 3 feet, 6 feet apart. That's for CBD production. And that's more like a Christmas tree. That's a whole different animal.
Sarah, we didn't quite hear what Rod said earlier. If you could repeat that.
I was talking about that upfront starter charge with chelated nitrogen,
Chilean nitrate.
Chilean, organic Chilean nitrate as a starter charge.
Okay, gotcha. Thanks.
Thank you. Thanks, everybody.
We think lunch?
Yeah, we can do lunch.
So maybe we'll take like a 10-minute break. So our group here can get their lunches and get back to the tables. Matt, is your group ready to present after that?
Yeah, we can present right after that. Faye, that sounds good.
10-minute break here.
So it's great to be here with all of you. So I'm Matt Ryan. I've presented at the NICO meetings in the past. It's, I feel like it's a really important meeting. And, it's always a pleasure to have the opportunity to share with all of you what we're doing in the Sustainable Cropping Systems Lab. So today we're going to be talking about improving no-till, our work on organic no-till, and there are a number of people that are co-presenting with me. And so I want to just take a moment and make sure that we can do some introductions and that you know who will be talking here. So why don't we just start in the list that's shown here on the slide. So Jake, can you just unmute yourself and say hello and just say a couple words about yourself and what you're doing?
Yeah, hi everybody. I'm Jake. I'm a master's student in Matt's lab. This is my first year at Cornell. Started for the last field season, and I've been working on all the organic no-till stuff and also some weed community work with Matt.
Thanks, Jake. Udi, you're next.
Hi, everyone. My name is Uriel. I'm a PhD student with Matt, and my work is on weed communities in reduced till systems.
Thanks, Udi. Chris, are you there?
Yes, I'm here. Yeah, my name's Chris, and I've been working with Matt for 8 years now, and much of it has been on organic no-till, and yeah, I won't really be presenting, but yeah, heavily involved with in the field research components of all the data that will be shared today.
Thanks, Chris. Annika?
Hi, everyone. My name is Annika. I'm a first-year master's student in Matt's lab. I'm focusing on weed management in organic no-till soybean. Excited to be here.
Thanks, Annika. Sandra?
Yep. Hi, everybody. I'm Sandra. I've been working with Matt since 2015. I'm lab coordinator for the Sustainable Cropping Systems Lab, and I work a lot with perennial grains, cover crop breeding, and organic no-till. And special thanks to our grad students today for the presentation.
Thanks, Sandra. Kristen?
Hi, everyone. I'm Kristen Loria. I'm a technician with the Ryan Lab and started in May of last year. So I work on all sorts of different projects with the group. Happy to be here. Thanks.
Thanks, Kristen. I also wanted to say thanks to Brian, Luke, Emily, and Faye for inviting us to present today. So yeah, we're going to be giving you an update on our recent work with organic no-till. And so we've been working on the system for a number of years. And so I'll be giving just a brief introduction, and then the graduate students will be talking about some of their research. So we want this to be as interactive as possible. I know these hybrid Zoom meetings can be a little rough sometimes. So please do interrupt us. I will try to take some questions in between our short presentations. So there's a series of very short presentations, and then hopefully there's some time in between where we can have some questions and have a bit of an open discussion. So that's our goal here. And so I'm going to kick things off here and just go through a couple slides just to get us thinking about why we're so focused on on organic no-till. So I want to start with this, this photograph here of moldboard plowing, right? And I have in the lower left-hand corner, the soil fertility and crop nutrient management standard, from the organic regulations within the National Organic Program. And so, this states that, organic farmers should only use tillage and cultivation practices that maintain or improve the physical, chemical, and biological condition of the soil and minimize soil erosion. So I'm teaching a class right now at Cornell, Principles and Practices of Certified Organic Agriculture, and we're going through the history right now in this part of the semester, and we'll be talking about the rules and regulations and the standards. And I feel like this is just important to recognize that soil health is inherent to organic production, right? And so some people might look at this photograph and be maybe even offended or concerned about the intensity of tillage. And I think it's important to recognize that in this case, the farmer is plowing down a cover crop, right? And so in many cases, even though moldboard plow tillage or intensive tillage is used on organic farms, we see a good increase in soil health indicators, including soil organic matter. And so it's because of that intensive use of cover crops and other amendments such as manure or compost that we can do that. We can use tillage for weed management, but also have increasing soil health, right? And so in this case, maybe not so bad, with this use of tillage. There are other problems with tillage. It's labor intensive, fuel intensive, of course, right? It takes a lot of time. But in terms of just soil organic matter, I feel like, you can make the case that, as long as you're plowing down cover crops and managing your soil in an effective way with adding amendments that you can balance or increase your soil organic matter. However, the problem with tillage in my eyes and the way that I see it here is that is really with erosion, right? And so this is from the same farm in Pennsylvania. And so this is shortly after corn planting, and you can see, this erosion that's happening. Tillage was used to prepare the seed bed, and then a heavy rain came along, and this is sloped land, but it's not a very steep slope, but incredible erosion here. And that's really what we are trying to guard against. I was asked over the summer, well, why are you doing this work on organic no-till soybean? And it's, the farmer was saying, we can grow good organic soybeans, with tillage. And it's really this issue here, soil erosion, that we're really trying to reduce and trying to work on with our rolled cover crop system, right? And so that's what we're going to be talking about using a roller crimper. And for those of you who are familiar with me and my research, you know that we've been doing this for a while. We've shared on our work at NICO in the past, but this is using a front-mounted roller crimper to mechanically terminate our cover crops. And really we're focused for a lot of our research on no-tilling soybean into rolled crimp cereal rye, okay? And again, trying to reduce that soil erosion. This is on flat land, over in Groton, where we were working with a farmer there. And we were seeing, even on flat land, this is back in 2017, we're still seeing a lot of washing with our tilled soybean production, right? So we know that there are a lot of benefits. Again, this top one here, protecting against soil erosion, but we also have collected data and have evidence to show that we can improve soil health, improve water infiltration using these thick cover crops, right? As mulch, we can reduce labor and fuel requirements, getting away from that tillage, getting away from all of the cultivation events that are typically used in organic soybean production. We can also, do other things. We can access fields in the spring when it would normally be too wet. And so just an example of that, you can see on the tires here, this is when we were planting an experiment several years ago. We were planting we had a rolled cover crop, and you don't see any soil here, but there is soil on those tires. And so bringing the planter out to the field, certainly had some mud sticking to those tires, and we were able to go in and plant when it was when we typically would have been prohibited from going into a tilled field because it was so wet that year, right? So we've been working on this for a number of years, like I've been saying, and we recently published this organic no-till planted soybean production guide. So this is available online. It's It's a booklet. We're quite proud of this. If you would like a copy of it, we're very happy to send you a hard copy, but it's also available as a PDF. So our past research summarizes our research up until about the past couple of years. And then since then, we've been doing some other work looking at optimizing equipment. So this is Chris Pelzer as part of a video showing the planter that we're using at Cornell for our no-till work, and talking about the good seed singulation that we get, the good seed placement. This has traditionally been a problem in these high residue, high biomass cover crop no-till situations. But with the technology that's out there today, with these improvements in planters, we can see that we can overcome that challenge, get good plant stands with the equipment. So we've also been looking at other ways to optimize the system. So this is a photograph from just a seeding depth trial that we were working on. Jake Allen will be talking next about some soil fertility work that we were doing, looking at using starter fertilizer in organic no-till soybean as a potential way to optimize the system. We've been thinking a lot about adaptive management and using decision support tools to help people avoid problems. And so this is included in our production guide. And then something new that we just started last year is looking at different tools. So Annika Roland will be talking about her research using this inter-row mower for mowing in between rows of 30-inch rows of soybean that have been no-till planted into cereal rye. So really exciting work with some of these new weed management tools. In addition to the inter-row mower, Annika will be talking about using a weed zapper in combination with a inter-row mower. If there's enough time, we will also talk a little bit about some of our work on organic no-till wheat using the same approach where we're rolling down cover crops. Now, in this case, summer cover crops, and then no-till drilling winter wheat behind it. So this is a little teaser or taste of what you're about to see from the graduate students. And again, very happy to make this as interactive as possible. We want good discussion here. So if you feel like we're talking too long, or if we're showing you some data that don't make sense, please just interrupt us, unmute yourself, and we will try to address that right on the spot here. So at this point, if there are no questions, I'm going to turn it over to Jake Allen, and he is going to share a little bit about his starter fertilizer work. So why don't we just move right into Jake's presentation. After this, because I wasn't really presenting anything all that new, and just giving you just a glimmer of what is in store here, we'll take a little break and have a moment after Jake's presentation before Udi presents for any questions about the starter fertilizer experiment and the work that Jake has been doing. Jake, why don't you take it away here?
All right. Thanks, Matt. And hello again, everybody. So I'm going to be talking about some work that we just recently finished up looking at this organic no-till soybean system, trying to see if starter fertilizer can increase yields in this system. So this was our main question here is whether adding some starter fertilizer at planting can increase our yields in organic no-till soybeans. So this rye that we rolled down in the system is really great for preventing things like erosion. But we have some evidence that maybe having the mulch over the soil can prolong cool soil conditions, decrease nitrogen availability for soybeans when they need it most. So before they start fixing their own nitrogen, and there might even be some delay of their own biological nitrogen fixation by these cooler temperatures as well. So we're thinking there might be something to do with that, and kind of the yield gaps we still sometimes see between organic no-till soybeans and tilled organic soybeans. So this experiment was kind of trying to get at that question. So what we did, we had 3 site years for this work. And we worked with some colleagues at the University of Wisconsin. to have one site year this past summer in up at their Arlington Research Farm. And then we had 2020 and 2021 at the Musgrave Research Farm here for Cornell. And for each of these site years, we had 4 treatments, just a control with no fertilizer applied. And then we had organic Chilean nitrate, so sodium nitrate at 167 pounds product per acre. All of these product per acres are to get 25 pounds of nitrogen per acre. So they all have the same nitrogen application. And then we have feather meal and poultry litter, both coming from Career Family Farms. So those were our 4 treatments. And what we did for planting, we planted organic soybeans into the roller crimped cereal rye at 234,000 seeds per acre. With this planter here, this is the JD 1755 planter. And we banded the starter fertilizer treatment. So in a 2x2 band, it's 2 inches to the side, 2 inches below the soybean row. And like I said, at 25 pounds of nitrogen per acre across all the treatments. And the roller crimping, sorry, not the drilling there, the planting and the fertility application were all done in one single pass operation. And then to sort of see the outputs or what happened with the soybeans, we collected both early season growth data, so height, growth stage, and also leaf greenness, which you use a little meter to measure chlorophyll fluorescence, just to basically give you a quantification of how green the leaf is. And then we also measured wheat and soybean biomass at peak soybean biomass and the soybean grain yield at the end. So we wanted to see both if there were early season growth benefits, if we could see sort of like sodium nitrates coming out ahead in the very beginning, but we also wanted to see the final endpoint. So does it actually impact yield? So just some, these are preliminary results. Like I said, we just finished up this work, but this graph is for the leaf greenness, and across leaf greenness, height, and growth stage, we did observe some enhanced early season benefits from the fertilizer application. You can see notably in sodium nitrate, there is an increase in the leaf greenness. We did the leaf greenness measurements over set growth stages. So V2, V3, R2 and R3 in Wisconsin, and V2, V3, V4, and R2 in New York. And we saw, some benefit, notably in sodium nitrate, feather meal in New York, also coming out ahead of the control there. And so we were wondering if this would then translate into some kind of yield benefit. And these are the yield results for the 3 site years. And just preliminarily across all the sites, these early season growth benefits that we saw didn't translate to increases in our grain yield. So you can see there might be some numerical differences between the control and the treatments, but there's no very clear pattern for what's going on, or for the fertilizer treatments providing a yield benefit. What you do see, interestingly, is the very different yields across the site years, with New York 2020 and Wisconsin 2021 having much lower soybean yields than New York in 2021. And we have some, we'll be looking into that a little bit. Basically, the takeaways here, we did see starter fertilizer increases, early measures of growth, and those are, again, height. The fertilizer treatments were advanced in growth stage as well, and they had greener leaves earlier in the season. But other factors, so weed abundance, rye biomass, and rainfall, these were all things that differed between the site years themselves. So those may be more important for system success, for getting really the maximum yields that you can get out of the system. And then in some, I guess, the benefits from the starter fertilizer might not outweigh its cost, though we will be doing some more economic analysis to see, with the price of organic soybeans being what it is, maybe there are some cases. But yeah, that's basically the project, and these are our teams in Wisconsin and New York. Yeah, any questions?
Thanks, Jake. Yeah, any questions from the audience, either online or in person there?
I recently saw on YouTube from Iowa Organic, an organic soybean grower, and for fertility, he used 60 pounds of sulfur, 15 pounds of boron. The reason he wasn't using poultry broadcast or anything like that was because of excess phosphorus for weed growth. What do you think about a program, 60 pounds of sulfur, 15 pounds of boron, more than likely broadcast?
Yeah, thanks for the question. Yeah, I think it's interesting, yeah, to see what other people are doing. Certainly, we have data, and you can have you can create weed problems if you over fertilize, and I think it's always good to be aware of a situation like that, where if you are seeing applying excess nutrients, yeah, you can just be feeding the weeds without any crop benefit. I am not sure about sulfur and boron. I don't have a whole lot of experience with research in that area. From what I understand, though, is that you would typically not see a response unless you're deficient, and unless there's a need for it. So if you are doing soil testing or tissue testing and you see a need for boron or sulfur, then there may be some advantages. But in terms of just a blanket or just a standard kind of application, I think you would want to be careful with that. The other thing here is, with nitrogen, we're seeing that nitrogen is a limitation. We're seeing yellower beans in our organic no-till soybean compared to tilled soybean, and it's a classic nitrogen tie-up from that cereal rye. We get a benefit, a weed suppression benefit from that nitrogen tie-up, but we do not. We also see that it's a little bit slower growth of our beans before they really start fixing their own nitrogen. So I see a note from Dan Gladstone. He says, "I know some conventional growers are applying sulfur now that acid rain is a less dependable source." Yes, and I think there's work with other people at Cornell showing sulfur applications can be beneficial in some cases in New York. Again, I think that's should be really basing those applications on some testing, though, to see if it's if it's needed. I don't know, Chris or others, any other thoughts on that?
The only other comment I have is, at least related to sulfur, poultry litter usually has a good amount of sulfur as well. Yeah, so when with Jake's experiment and the different fertility sources used, two of them were one was poultry litter, other one was feather meal. We were focused on standardizing the nitrogen. But yeah, there obviously is other nutrients that are being applied through those sources, and sulfur being one of them, since sulfur is pretty good quantity in poultry litters. That's all I have.
Did you monitor the nodulation of the soybeans between the different treatments? Is there any difference in speed of development?
No, we did not monitor nodulation. Jake, please, chime in here if you have anything to add. But nodulation is something that we've thought about, and certainly you hear these stories, and there are research showing that soybeans can get lazy if you're applying nitrogen, and that's goes against kind of a lot of the philosophy and what we're trying to do with legumes, and having them provide their own nitrogen. The quantifying biological nitrogen fixation is a bit tricky, and the root excavations that are required for just even counting nodules was a little prohibitive for this research. But great question, and something for us to focus on in the future. Jake, do you want to say anything about that, or thoughts about it?
Yeah, I think it is a great question. It was definitely on the table when we were designing this. I know our collaborator Erin Silva had done some stuff where she measured nodulation in Wisconsin and was a little leery of doing it for this experiment too, because it is very labor intensive to do it, especially at 2 sites in the season.
Were you charting wheat biomass with these different treatments?
Yep. So we measured weed biomass, I think at R5 soybeans, and there were, again, more preliminary analysis. There were no differences between the treatments in terms of that. Maybe a slight increase in the 2021 New York site year for sodium nitrate, but with the banding, it seems like maybe it was relatively even. And we got some very good rye suppression as well.
Was there a difference with compared to the control?
No, compared to the control, at least preliminarily, what it looks like is no difference with the treatments for weed biomass.
I have the hard copy of the pamphlet that was put out with the growers in New York State. And it seemed like the common consensus was that it had potential, but I don't know that I'm going to pursue it for one reason or another. I truly like the idea of that system. What are your success rates?
So question about success rates with organic no-till soybean, is that right?
Correct.
Yes, I feel like our success rate is quite high. I think we've seen very good yields comparable to our tillage-based system. Where we run into trouble is where we have very dry spring conditions. And typically in the Northeast, our springs are wet. We have too much moisture in the spring. Spring rains, prevent people from going out doing tillage, prevent timely cultivation, weed management events. So that's kind of the context that we think of oftentimes. But we do occasionally have very, very dry spring conditions, and that is when the soil becomes very dry underneath the cereal rye cover crop, and that's when we have stunted soybean seedling growth and problems and larger yield gaps. So it's I think that goes back to that decision support tool and adaptive management. We really want people to recognize that this takes advanced planning. It takes the systems approach. And we're trying to identify time points and thresholds where farmers can make a decision and change the approach that they would like to use, either based on the stand of the cereal rye in the spring and the amount of weeds that are present. And then also right before planting, there's also an opportunity to, if it's very, very dry, the alternative is to not try to terminate it, but let that cereal rye grow and harvest it for grain. So sometimes, that is something that we're exploring. I know that doesn't work for everyone, and that could be disappointing if you're planning on a big soybean crop and considering the differences of the profitability there. But what we're really trying to do is have people avoid getting themselves into trouble with no-till planting into ultra dry conditions without any rain in the extended forecast. So I think there, aside from that one kind of specific weather condition and circumstance, we've had very good success with our organic no-till soybean. Corn, on the other hand, organic no-till corn, no-till planted into a legume cover crop, that is much more variable. I know there's a lot of interest in that. We're interested. We're still excited about the potential there, but it's been extremely variable. Sometimes it works beautifully, very, very high yields, incredible growth and great weed suppression. And other times it's a complete miserable failure. And so a lot of times with corn, it's been a problem with our getting a good plant stand, a good population of corn. So, but with our beans, fairly good success, I would say.
On the corn, are you using vetch or rye?
Yes, yeah, we have focused on using vetch. I feel like this nitrogen problem that we're talking about with soybean, and that or you can think about it as a benefit in terms of the nitrogen tie up when we're in terms of the weed suppression that we get from that. But when we're whenever I've seen organic corn no-till planted into cereal rye, it's always been a failure. I don't, there are a number of conventional farmers, a number of no-till farmers, soil health enthusiasts that have tried planting green and roll down cereal rye no-till plant corn into it. And I feel like under conventional with conventional tools of adding fertilizer and managing that nitrogen deficiency there, can perhaps work in some cases. I think there is a lot of potential for disease problems with the grass cover crop, and then a grass cash crop. And so what we have done is really focused on using hairy vetch. I know like hairy vetch is a dirty word for some people, and that people don't plant it if they're growing small grains. And I totally understand the hard seed problem and issues. There are breeders that are working on improving hairy vetch and getting rid of the hard seed problem. And I think there's potential for that in the future. But you can also get yourself into trouble if you have small grains in your rotation and you're thinking about trying to roll down hairy vetch. If there are any escapes, it could be problematic.
What about something like Berseem clover that would winter kill?
Have not tried Berseem clover. We have worked with crimson clover in the past. Crimson clover, it's a legume, but really see a huge difference between crimson clover, a winter annual legume, and the other winter annual legume that we've worked with, hairy vetch. Huge difference in early season growth and greenness of nitrogen deficiency in corn. So hairy vetch, you can get away. I think it will produce enough. Crimson clover doesn't even come close. It's producing enough nitrogen to drive a corn crop. Other people may have worked with peas in the past. It's been challenging. I have not seen any success reported out there with Berseem or other clovers though.
Dr. Aaron Silva has done some work with pre-planting beans ahead of the roll down, like 40, 45 days of no roll down. And do you have any comments on that?
So I cut out a little bit there. I think you were asking about the planting date. So typically we've been planting at anthesis. So rolling down our cover crop and no-till planting soybean at the same time in a single pass operation. We're collaborating very closely with Dr. Silva out in Wisconsin. And yes, this system where they're going in at boot stage, early boot, and no-till planting beans, and then coming back later and terminating the cover crop. We have seen yield benefits from that system, from that approach. I think there's a lot to be said for that. In our other work, we've seen earlier planting does provide a yield benefit, and that we may be constraining our yields with waiting till anthesis. So we have a trial that's being replicated right now in Wisconsin and in New York, and we'll be looking at that exact question, trying to get some more data around that idea of going in at boot stage and then coming back later and terminating the cover crop after the soybean is already established. But yeah, really exciting.
What's your rotation, like 4 or 5 year rotation?
Yes. So in our long-term experiment, what we've been doing is using a forage, a summer annual forage crop, sorghum Sudan grass, to provide the opportunity for a very early establishment of cereal rye. So then we would roll down our cereal rye no-till plant soybean. We've tried to do some winter triticale in the past, but we've shifted, with wet fall conditions. It was really, and also our harvest tends to be a little delayed. We have a little bit slower time to maturity or time to harvest with our no-till beans compared to our tilled beans. Those two factors in combination really pushed us to using spring triticale. And so that has worked well. Go to spring triticale to red clover to corn. And then in the following year, we've interseeded cover crops. Yellow blossom sweet clover, annual ryegrass into our corn, and then the following year manage that with some tillage, and then go to our sorghum Sudan grass, and then back into our cereal rye for our no-till soybean. We feel like there are a lot of opportunities to modify and adjust, and it's really that forage crop that allows us to make things work. And having the triticale after the cereal rye, there's some benefit there. If that triticale is managed for forage, sometimes we get some volunteer cereal rye. And so spring wheat, we've seen some problems where there's been rye contamination where you follow organic no-till soybean with wheat. There's sometimes a potential for rye contamination, but that really depends on if you're managing, how you're managing that rye cover crop, and if you're getting good effective termination at rolling.
So there's no tillage for the corn?
There is tillage for corn. So this, very, very key message here. What we're talking about is rotational no-till. So we're no-till planting soybean into this cover crop. There is tillage used at other points in the rotation. We're really excited. People, I don't know, may think we're crazy, but we're really excited about the potential for a more continuous no-till system, organic no-till system. And I think with some of the tools like the weed zapper that Annika will talk about, and to the inter-row mower using high biomass smother cover crops like buckwheat, I think there's potential for us to get closer to a more continuous organic no-till system. But right now, everything that we've been talking about so far is really tillage is used at some points in the rotation, certainly before corn to terminate red clover. And it's really the no-till part of soybean that is, our focus. So we're taking steps and trying to be careful along the way, but our goal is to move closer towards really eliminating as much as possible tillage in our complete rotation.
What about the Harpy bioherbicide?
The herbicide. Yeah, Klaus was talking about that. I haven't tried it yet. I think it sounds interesting. Last I checked online, it was not yet OMRI approved. Does anybody know if it's allowed in certified organic production at this point?
Sorry, what was the name of it?
HARP. It's HARPE. It's bioherbicide, a new product. They say online that they are submitting to OMRI for approval, but I haven't seen the stamp of approval yet. So I think there's potential there. We've been more focused on mechanical tools. I feel like there's a lot of potential with the inter-row mower. So with that said, this discussion is great. I'm keeping an eye on the clock. I want to just make sure we have provided enough time for Udi and Annika to present. So perhaps we should shift over and let Udi give his short presentation. He's been looking at some really interesting research, some data taking more of a community approach and trying to understand, well, how does mulch affect the weed community? What traits, what species are being suppressed and which are not being suppressed? So if everybody's okay, we'll turn it over to Udi, and then we'll come back to discussion after this. And then again, after this, we want to make sure that we save time for Annika, because she has some really cool new data on the interrow mower and on weed zapping. So Udi, why don't you take it away here?
Okay, great. Can everyone see my screen?
Yes.
Awesome. All right. Hi, everyone. My name's Udi, and today I want to try to describe how cultural weed management can affect the composition of weed communities in organic no-till. As we've gone over with Matt, organic no-till is promising because it can reduce the potential for soil erosion, particularly in the Northeast. But without tillage or synthetic herbicides, there's really an increased need to understand how to effectively apply cultural weed management for organic no-till systems. Because I think the last thing that an organic no-till farmer will want is a field that's overrun with perennial weeds. So to understand how cultural weed management can affect weed communities, I'm using weed community assembly theory to describe what weed management will do to your observed community. And the idea here is that different management practices filter out weeds that don't meet a set of trait requirements. So for instance, if you have a really high crop seeding rate, you'll probably filter out weeds that aren't shade tolerant, right? Because that dense canopy will shade out small weeds. Broadly, to all of agriculture, I think that community assembly theory is quite useful because at its core, a lot of crop production is essentially placing these filters on plant communities to suppress weeds and optimize crop production. And again, research on agriculture as a whole has shown that things like herbicide use, tillage, and fertility do affect weed communities through these filtering processes. We also know that management practices filter weed communities to different intensity. And so to me, this makes sense. Like something like broad spectrum herbicide will filter out all weeds that don't have a resistance trait. But something like selecting a more competitive crop cultivar will filter weed communities less intensely. And the challenge here is to really understand, like, okay, how do cultural weed management practices in an organic no-till setting filter weed traits? Because if we know that, we can anticipate how certain weed management programs will affect weed communities in the medium and long term. So I was interested in two cultural weed management practices: the density of no-till planted soybeans, as well as the thickness of the cereal rye mulch. Okay. So to see how these two cultural weed management practices affected weed community composition, I took advantage of an experiment that had been run in Maryland and Pennsylvania. And this experiment developed two gradients, one of soybean density, which was 5 rates of soybeans. And these 5 rates of soybeans were no-till planted into 5 different cereal rye mulches with differing thickness. Okay, and so this was replicated in 4 blocks per site for 100 plots, right? We have 5 soybean seeding rates, and each of these seeding rates is no-till planted into 5 levels of cereal rye mulch biomass. Now, we sampled each of those plots and got weed biomass at the species level, and also recorded the density of soybeans and the biomass of cereal rye mulch. And using that data, I wanted to see whether these two cultural weed management practices affected weed suppression and weed functional traits. So I looked at 4 traits. Okay, so I looked at the life cycle, seed weight, emergence timing, and height of each of the sampled weed species. And the reason I looked at life cycle and seed weight is because we expect that thicker cereal rye mulches, or just broadly cover crop mulches, will filter out weeds that don't have a large amount of emergence resources, right? A thicker mulch is harder to penetrate. So species that have small seeds or don't have vegetative emergence, like some perennials, should be filtered out from thick mulches. We looked at emergence timing and height of each weed species in each of these 100 plots to understand how soybean density affected weed communities. And the idea here is that weeds that have a faster emergence timing and can grow taller might be able to outgrow the soybean canopy and escape the filtering effect of shading, right? There'll be increased shading at higher soybean seeding rates. So, just to go over what I'm going to present, I'll look at weed suppression by sharing how just changes in weed biomass occurred. And then I'll look at functional diversity. So these are the traits I just described by using community-weighted means. And you can just think of community-weighted means as the average amount or the average prevalence of a trait at different levels of cereal rye mulch biomass and soybean density. So for instance, the average seed weight at a high amount of cereal rye mulch biomass and a low amount of soybean density would be an example of CWM. And I'll be presenting my figures in these graphs, and these graphs reflect back on how we sampled the experiment. So remember, we sampled each of the 100 plots and we counted the number of soybeans. So these are going to be the lines you'll see where this like pinkish line is 0 soybeans per acre. And these blue purple lines are 300,000 and 400,000 soybean seeds per acre. The y-axis is always going to be a weed variable. So whether it be just total weed biomass or the average seed weight, etc. And then we also sampled the thickness of the mulch upon which those soybeans and weeds were growing. And that'll be the x-axis, right? So the further along this x-axis we get, the thicker the cereal rye mulch. And when we look at just total weed biomass, as well as just the annual weeds, we can see that increasing the mulch biomass, as well as increasing the soybean seeding rate, reduced total weed biomass and annual weed biomass. Okay, right? These lines are decreasing along the x-axis and decreasing as when you go from 0 soybeans per acre to 400,000 soybean seeds per acre. And this is where it gets really interesting, because when we only look at perennial weed biomass, we see that there's no effect of increasing cereal rye mulch thickness, okay? But increasing the density of no-till planted soybeans led to a meaningful reduction in perennial weeds. And I think this is pretty major because in organic no-till systems, perennial weeds tend to be a big problem. Okay, so that was an interesting result. Now, these graphs are, again, the same layout, but right now we're looking at average seed weight across different mulch biomass and different soybean seeding rates. And what we can see here is that these lines are fairly close together. And effectively, there was no effect of increasing soybean density on the average seed weight of weeds. However, we can see that mulch biomass was an effective means to reduce the amount of smaller seeded weeds in the weed community, right? The average seed weight of weeds is increasing with mulch biomass. And that aligns with my hypotheses. Thicker mulches require more emergence resources to penetrate through these mulches, selecting for heavier seeds. Another variable I looked at was emergence timing. And here, remember, I hypothesized that soybean density would be selecting for a greater proportion of early emerging weeds, and I did not find that that was the case. Okay, I found that soybean density had no effect on the proportion of early emerging weeds. However, as you can see by the reduction in these lines across mulch biomass, increasing cover crop mulch biomass was suppressive for early emerging weeds. And this is quite significant because when we replicate these plots with weeds that emerge in the summer and later on kind of in the early fall, we see that mulch biomass has no effect on these weeds, right? These lines would be straight. And what that means is that in a roller crimped cover crop system, mulches are most suppressive right after they're rolled, right? As the mulches degrade, they become increasingly weaker and weaker mechanisms of weed suppression. Now, the final variable that I looked at was weed height. And as I had predicted, increasing soybean density tended to increase the average height of weeds in the community, right? There's a lot of space between these lines. And so what that means is that taller weeds had a greater ability to escape the shading from a more dense crop canopy. So just in conclusion, what we found is that weed suppression can be meaningful in organic no-till systems. However, to get effective weed suppression, it's really important to use multiple tactics of cultural weed management, because something like increasing your cover crop mulch biomass is really effective at suppressing annual weeds and suppressing weeds with small seeds, but it won't suppress perennial weeds. And that perennial weed suppression can be accomplished by increasing your no-till cash crop density, right? Increasing soybean density reduced perennial weeds and also had an effect on shorter weeds. So I'm happy to take any questions, but Annika will be looking at more mechanisms of multi-tactic weed management. Thanks.
Thanks, Udi. Yeah, it's always awesome to see the weed ecology coming out here and thinking more deeply about the weed suppression that we're getting and the effect on the weed community. I am going to suggest that we hold questions right now and then go through Annika's talk, where she'll be talking about some of the same things here, soybean density as a weed suppression tactic, and some other tools. And then we'll have a joint kind of weeds discussion after this. So if people are on board with that, I think we'll just get right into Annika's presentation. Thanks again, Udi.
Thanks, Matt. Let me just share my screen. Okay. Can everyone see my screen?
Yes.
Great. Okay. So I will be talking kind of continuing Udi's presentation about weed management techniques. My presentation will be covering a deep dive into 3 different physical and cultural weed management techniques in organic no-till soybean. So these are the questions that we were looking at in this experiment. Our 3 weed management tactics, which I will get into later on, are a high soybean planting rate, use of an inter-row mower, and a weed zapper. So we were looking at which weed management tactic is most effective in terms of cost and yield, and also in reducing weed biomass, and then do the combination by using both, the inter-row mower and the weed zapper together, increase these metrics of success. So here are just some brief methods. This experiment was completed from 2020 to 2021 in Aurora. It will be being repeated this year, so more results will be available next year. There were 3 different fields in this experiment. 2 had cereal rye cover crop, and one of those fields had very, very few weeds, and one was moderately weedy. And then we had a 3rd field where there was no cereal rye cover crop and the field was tilled before soybean planting. I won't get into all of the details here, but you can see the variety and the machine used to plant the cereal rye. And then in early June, we terminated the cereal rye and planted the soybean as part of the single pass operation at rolling. And the seeding depth was 2.2 inches. And so I mentioned before that there were 3 weed management strategies. So these can be seen here within the 9 treatments that we created in each field. Oops, I'm sorry. We have our control, our high seeding rate, our inter-row mower, our weed zapper, and then just abbreviated here, a combination of each management technique, all 3 together, and then a weed-free treatment to assess what soybean yields would be if there were no weeds at all. So just to get into the high soybean seeding rate, increased soybean density leads to a denser soybean canopy, which can kind of be seen in these pictures. And this canopy blocks light and nutrients from picking up the weeds. And we chose this weed management strategy particularly because it targets within row weeds. And so this is important because for the inter-row mower, this rotary machine has 5 separate rotary mowers, which travel between crop rows to target the between row weeds. So this experiment has a spatial dynamic as well. And as you can see here, this is a picture of our fields with no cereal rye cover crop a few days after it was between row mowed. And we still have a lot of wild mustard here coming up above the soybean canopy. Well, we target these weeds above the soybean canopy with the weed zapper. So you can see here that this is a new piece of technology where the generator is attached to the back of the tractor, and we have an electric boom over here, which goes above the rows of the soybean canopy and literally zaps the weeds. And we found that plants with a high water content generally die quicker than plants without. And here is a picture of a ragweed after being zapped with the weed zapper. And this is only a few days post zapping, and we found that the weeds generally become necrotic, fully necrotic about a week after zapping. So I'm just going to quickly go through some preliminary results. So a few slides, I mentioned that there were 3 fields. Field E4 was the one that had cereal rye cover crop and very low weeds. So you can see when we collected weed biomass in every single treatment, very low weeds. Field X East down here also had cereal rye cover crop, but more weeds. And then V Northwest did not have the roller crimped cereal rye. And so what I kind of want to point out in this picture is that every single treatment that contained the inter-row mower, you can see like qualitatively that there was less weed biomass with these combinations, and the high seeding rate and weed zappers was almost comparable to just the weed zapper alone. And then these were our soybean yields for the treatments. Again, field E4 had almost no weeds, very, very good rolled cereal rye, and V Northwest does not have the roller crimped cereal rye. And what I want to point out here is that this combination of using the high soybean seeding rate and the inter-row mower did produce the highest yields in terms of field V Northwest and XV, and that is something that we are looking into. And so the takeaways from this experiment was that the inter-row mower was more effective at reducing weed biomass than the weed zapper, and that using a combination of practices decreased weed biomass and increased yields more than the individual practices on their own. And this is the acknowledgements and funding.
Thanks, Annika. Yeah, so I think there's time for a few questions. So I know that these tools may be new to some people. The inter-row mower is something that was custom made by a machine fabricator in Canada, and that's a part of a project with the Farm Hub, the Hudson Valley Farm Hub. But I think we're going to see more of the inter-row mower, more models out there. So, but very happy to have Annika and Udi take any questions that there might be about the weeds research that we've been doing.
In your seeding rate trials, was there any difference in spacing between the rows, or was all the variable rate within the row?
So I believe the question I can answer for my experiment and Annika for hers. Was there any differences in seeding rates or placement? And no, the rows for the experiment I presented were 7.5 inch rows, I believe. But regardless, row spacing was the same for me.
Yeah, row spacing was also the same for my experiment.
Yeah, so in Annika's, just to be super clear, Annika's work was on 30-inch rows. Udi's work was on 7.5-inch drilled beans.
What was the organic matter percent in the 3 different fields? How high was it?
So we're in the upper 2s to low 3s. I don't know if Chris has the soil test results, or if we. But it's pretty standard. I wouldn't say that it's a field with a very high organic matter level for our research farm, or one that was very low, but we're averaging right around 3%. Chris, if you have anything that additional information, please chime in there. But
yeah, I think you covered it, Matt. Yeah, all the fields are fairly similar in terms of organic matter. I don't know off the top of my head the percent, but yeah, like Matt mentioned, some fields at the Musgrave Research Farm are like 2.5%, but yeah, the upper range is like below 3% for organic matter.
that one field with field E4 that had the really high yields in it, that was very, very clean. That was managed conventionally prior to this experiment. And so there wasn't a very high weed seed bank, soil weed seed bank, whereas the other fields, they were managed organically previously, and they had a bit more of a weed population, a bit more of a soil weed seed bank. So we're thinking that's probably some of the differences that we're seeing there, at least in terms of the amount of weeds anyway, just the previous management.
Why didn't the weed zapper work very well, and does it take a lot of energy?
Yeah, so just want to acknowledge that we have Lynn Sosnowski on line 2 here. She's also doing some work with weed zapping. This was really our first experience with the weed zapper. Annika, I don't know if you have anything to contribute to this. This is something that I think we're all learning about, and I think the efficacy varies. Sometimes we might think, oh, these tools should be more effective, like looking across the fence and saying, oh, how come there are so many weeds in that conventional field and where they're using herbicides? Well, sometimes things don't work out like you think they should. And I think that's, we're still learning with the Weed Zapper. Maybe, we're looking at timing, the environmental conditions, but
Yeah.
really we're at the early stages of understanding how best to use it. And but I want to make sure that Annika and also Lynn have an opportunity to chime in there and see if there's anything to add. So.
Yeah, there's a lot of things to think about when using the Weed Zapper. We found that if there's a large amount of weeds that hit the electric boom at once, the system gets overloaded and then shuts down. So that's something to work on. Using the hydraulic system to lower or raise the bar is also something. Weather conditions. So yeah, we're really excited to work with the Zapper again this summer, and I think we're going to troubleshoot a lot of the issues that we encountered last summer. Also, just to quickly address the previous question, I do have my organic matter content, and for that field that yielded the really high soybean yield, the organic matter content was 3.86. All of them were above 3.
Hi, Matt. Thanks for, I'm also working with Weed Zapper, and I'm going to point out Josh Jers from Prayer Family Farms, who I'm working with on the Weed Zapper, is also on this call. And Josh and I can tell you that we've had a lot of discussions on this, and there's real differences in the sensitivity of weed species to the Weed Zapper. I think maybe Annika and Josh would agree that, kind of see like sort of a hierarchy of success with like lamb's quarters, pigweeds, then, ragweeds, and then the velvet leaves and the giant ragweeds, and then the grasses, so some of those tougher weeds and those grasses, which, tend to be not as succulent as some of the broadleaves, and they tend to be more droopy and don't come into contact with the bar as readily, are there's definitely biological issues like with the weed itself. Annika alluded to their soil conditions, soil moisture. Josh and I have spent a lot of time talking about soil moisture can impact the conductivity, and that can affect success or injury potential in the case of, some certain crops. And then, there are just timing issues. Not all of these weeds are up at the exact same time. The lamb's quarters emerges earlier, and then the pigweeds, and then so maybe by the time like your canopy is closing in, that's when your velvet leaves, are starting to emerge above that canopy, and maybe you just can't get a tractor in at that time safely because of canopy closure. And Josh and I have talked about, he's talking about putting, little wedges on the front of his tires to part that canopy and make, extend that window of opportunity. So there's a lot of reasons. And what Annika is seeing and Matt is seeing and Josh and I are seeing also, I can tell you a lot of growers are seeing throughout the US, because I've talked to several in the Midwest. We're also using the technology. And all have kind of hit on some of the very same topics and how to extend our opportunity. And Annika brought up an excellent point about the number of weeds diluting the current through, having a lot of weeds diluting the individual current that goes through a single plant, and being clean, really clean at the start and staying as clean as possible before using this technology is pretty crucial.
Thanks, Lynn. Yeah, absolutely.
You're using soybean seeding rate to control weeds. Perennial weeds particularly. Could you see more weeds in the seed row or between rows? And since then, we found out that they're on 7.5-inch rows, and how that might correlate to 30-inch rows.
Yeah. So, yes, typically a lot of times what we're seeing with weeds is that they're actually in between rows when we plant on 30-inch rows with our organic no-till soybean. Many times our worst or the most the dominant weed species that we see in our research fields is common ragweed. And that is typically emerges before the cereal rye is rolled down. That's an annual species, right? But it's emerges before the cereal rye is rolled down, and then it survives the rolling. But it tends to be in between the rows of soybean. I feel like it is actually controlled somewhat by the actual planter. So if a planter's going over it in that space right in the row, we don't see common ragweed. And this is kind of like the opposite kind of situation with tillage and interrow cultivation, where we often see the weeds right in the row with the crop. Here it's different. For perennial weed species, it's not, I'm not sure we're seeing that same exact pattern. We think that the Udi's work with the showing that reduction in perennial weed species when we increase our soybean planting rate, we think that is fairly transferable from 7.5 to 30-inch rows. I think the mechanism there is really that shading, and if we're getting faster canopy closure, whether or not we're in 7.5 or in 30-inch rows, by increasing our seeding rate, we should have that same effect on perennials. But yeah, you bring up a good point there. There were differences, and we're typically doing planting. The reason why we felt that we can have better control in that experiment with Udi using the grain drill, and so going on 7.5-inch rows. So that was some older data there. Anymore now, we are really using a no-till planter for our organic no-till soybean work, and we feel that we can get better seed placement, going through the mulch with the planter. Udi's done a number of other, some other trials. There's been some other work coming from the lab here showing that this higher seeding rates, it tends to pay off. We get better weed suppression, higher yields at our higher seeding rates. So beyond the perennial weed control, it does seem to pencil out for us, and we're seeing overall better performance of our beans.
How high of a seeding rate do you think you need to be at to make a difference?
Udi, in your economic analysis, I think you were coming in at like 225, right? As established plants out in the field. So that's a bit higher than what we're seeing, certainly way higher than what we're seeing as a recommended rate in conventional beans. So there are a couple of factors here. If we get a small increase in our yield, it tends to more than pay for itself, given the high price of beans, $35 per bushel, and then the lower seed cost to conventional. So, conventional beans are more expensive, and so there's this tendency of, like, the question is, how low can you go in conventional? In organic, it's really on the opposite extreme here. It's, we're seeing some advantages of going up really high, 225, with our economic optimum for feed grade beans with Udi's work, maybe a little bit higher with our food grade bean trial.
Yep. So to be exact, there's typically plateaus in the amount of weed suppression and yield benefits you get at higher seeding rates. And as Matt said, the specific numbers from trials are around 250,000 seeds per acre for food grade soybeans, and around 210,000 seeds per acre for feed grade soybeans, accounting for differences in profits and market prices.
Is that seeding rate or final stand?
That's seeding rate. So that is seeding rate using a no-till planter, not a drill. One of the major impacts to overall yield is crop establishment. So, yeah.
Did you say food grade and feed grade?
So food grade, we found that the optimum seeding rate is around 250,000 seeds per acre. Feed grade, we found that the optimum seeding rate is typically between 210 and 215,000 seeds per acre, or 100,000. Sorry for both.
Why is that?
Typically, the food grade has a little bit of a higher market price. So you can justify the higher input, the higher cost of increased seeding rates than the feed grade, which sells at a little bit less in the market.
So you're looking at dollars per acre versus yield?
Yeah, we're looking at dollars per acre across seeding rates. And when that benefit is highest and when you start, so it's kind of like a mountaintop, right? Where there's a maximum profit across seeding rates, and then you start losing money because yields don't increase at higher seeding rates and your costs are just going up because you're buying more beans and you're not selling them or not getting a good yield.
Perennial weed species were you identifying in your plots?
So these will change per site. As Matt said, just broadly in organic no-till systems in New York, ragweed is typically the #1 annual weed, as Matt said, and I completely concur with that. And then perennial weeds is kind of a mixed bag. Like in some studies, we've seen that some perennial bindweeds are really problematic, and in others we don't. We don't see those weeds. So on the whole, if we were to generalize in New York, I would say ragweed.
Just a comment, I see Rodale in their no-till soybeans, if they have a excessive number of weed escapes, they'll come in with a high residue cultivator.
Yeah, we've done a lot of work with in the past with high residue cultivation. I feel like the inter-row mower is a better tool. You kind of can reduce some of the benefit of having that mulch by using a high residue cultivator. It can be effective. I feel like different researchers are using them different ways, so it's hard to generalize in terms of the equipment. Here at our research farm, we have a John Deere high residue cultivator. Other places, might be using a Hiniker or a Sukup, and so they vary in terms of their effectiveness and how they impact the soil. But I feel like if you have a no-till field and you have that ride mulch, what we're trying to do with the inter-row mower is really maintain that mulch, maintain that ground cover, rather than going through all the trouble of getting that mulch there and then ripping it up in between our beans once they're established. So, but yeah, that's another tool that's being evaluated that there's been work on in high residue cultivation.
The reason I say that is because from what I understand, weed zappers are, not everybody can afford one. And I don't know what the price of a mower is either. And I know that we're geared towards no-till because of carbon and, that's where everything is headed. But what about a middle of the road approach using rotavators and high-speed discs where you're keeping that residue in the top 4 inches? Not conventional tillage, not no-till. I think that for a lot of people might be a more reasonable approach financially.
Yeah. Appreciate the comment there. And so, yeah, some of the tools that we're talking about here can be pricey. The weed zapper, especially inter-row mower. This is a custom-made tool for us. So we were paying, around $30,000 for that. But that was, again, is custom. We are seeing inter-row mowers that are now commercially available. So there is at least one that's that you can purchase. Go on to a website, check it out. However, the can be cost prohibitive. So certainly is something to keep in mind here. We're trying to really push the envelope with some of this work here and see what we can do. I see a lot of people that are in that are no-till farmers, conventional no-till farmers that are interested in soil health, interested in ecology, and interested in a lot of the principles of organic management, but they are just really will not use tillage. And so this is, trying to bridge that gap, and seeing what we can do with really this alternative approach of really trying to no-till plant into these cover crops. Certainly, yeah, other approaches, growing perennial forage crops, you can really regenerate, your soil health quite effectively. You can manage weeds going in with perennial forage crops. That's a great strategy. That's a tried and true strategy for reducing tillage. You're reducing tillage frequency. So I see a lot of benefits with that. When you're talking about using a high-speed disc, I mean, there's costs associated with new equipment there as well. See that there's certainly some labor savings. I think that's worth talking about. I know myself, when I've looked at chisel plowing compared to moldboard plowing, we've always had a lot more problems with a chisel plowed ground in terms of weed suppression. There are plenty of farmers. Dan's on the call here, and maybe he can say a little bit about the chisel plow that they use at Oshner Farm there, and so that's a chisel plow that has wide sweeps, and I think they've been more effective. So I do think there are opportunities, and so there may be some farmer innovations, some things that people are working on that may be more of a middle of the road approach where we can see some of this tillage reduction and accomplish our goals, but maybe make it a little bit more approachable and maybe more affordable to get started. Dan, do you have any comments on that cultivator that or that chisel plow that you're using? I'm not sure if Dan's looks like he's muted and may not be around, but was there another follow-up to that or response?
What they did to their field cultivators, they put wide sweeps on it. They use it to undercut the roots.
Exactly, yeah.
You showed a slide there early on of establishing winter wheat rolling down in summer cover crop. How successful is that?
Yeah, so that has been I would say successful. So yeah, I'm going to just share my screen again for a second, if that's okay. Can everybody see this? Our organic no-till wheat.
Yes.
So, we tried, we were just trying some different things here. We had this researcher from Australia came up and he says, we don't grow corn and soybeans, we grow wheat. And, can we do the same thing with wheat? And so this is a collaborative project. We actually rolled down soybean here. This is really strange and wacky, but we tried rolling down sorghum Sudan grass, buckwheat, radish, right? And we see some good reason to be doing this. So these were our treatments. We had sun hemp in there as well, right? So you can see our treatments, our seeding rates, and then we had 3 timings too. So 3 different timings for our planting of our summer cover crops. Buckwheat, I'll just cut to the chase here. Buckwheat seems promising. We think that there's some potential benefits with buckwheat. This is how much biomass was produced. Apologies, in advance here, showing you some results here with metric units. The relative differences are important here. You can just assume if you add a 0 here, you can almost assume that this is 4,000 pounds per acre here. So just add a 0 and then just change it from grams per meter squared to pounds per acre, and you're pretty close. But you can see the biomass production of these different cover crops planted at these different times, early, mid, and late. Again, those correspond to these different dates: July 12th, July 30th, and August 20th. So that was the mulch biomass, the cover crop biomass. Saw some really good weed suppression here, especially with that high biomass from the sorghum Sudan grass. And then we have our tilled control here. That's that red line going across here. This was, we actually had better weed establishment when we had some mulch there. I think we maybe beat up our soil a little too much in our tilled control and planted maybe a little too deep. Not sure what happened. May have been some crusting there that prevented some weed establishment in our tilled control, but we had very good establishment in terms of weed density across all of our different cover crop treatments there. And then when we look at yield, so these are the yield data, we had higher yields in our tilled control. Okay, so that's that red line going across here. And so just know, some decent yields here. 3,000 or 300 grams per meter squared here. So this is about 45 bushel per acre. Okay, so just give you a reference line. Okay. So, but you can see our buckwheat, early planted buckwheat and our early planted sun hemp intended to do well. They were comparable to our tilled control. So we see some potential here. I think, this is, the first time we ever looked at this. I think we'll be doing more of this. Udi's done some work with this now, following up, trying to look at different cover crop and cash crop combinations that work well. But this would be key, using buckwheat, for example, as a smother cover crop that we can roll down. This is kind of the next step that we're looking at in terms of getting a little closer towards our continuous organic no-till system here. Any other questions about the wheat work that we were doing?
I got a comment. I've been doing this for almost 30 years of organic stuff, and I got a lot less soil than I used to have when I started conventional. And it's what you're working on is great. It's the only way to go, I think, if you figure it out. Because you just can't keep doing what we're doing. That when you go out there and cultivate, it's just like starting over every time. And the rains come so heavy nowadays, they just take it right away.
Well, I really appreciate that comment. Sometimes, it's easy to get discouraged when you have a failure, but that's how we learn. And we've had a lot of failures, so we're happy to be working on this. And I think connecting with all of you is makes it special for us. So anytime that you have ideas that you want to explore with us, we're very open to doing on-farm research and coming out, working with all of you, sharing any information that we have. So, please do get in touch with us if you see opportunities, or even if you want to just give us some suggestions. And, we get some of our best ideas talking with people like yourself. And so we really want to, try to take those and take a closer look at, interesting things that other people are doing.
One question, were those fields that were rolled down, they were maybe not intended, but they had that soybean crop since May that you rolled down, or were they just put on as in July after wheat or something that you rolled down and then planted your wheat into? I mean, the previous year, summer that you rolled down for your wheat, winter wheat.
Yeah, Norman. Yeah, thanks for the question there. So in our research, we're often going into, we have trials and we carve up these fields, and it's it's research, but a lot of times we're going into a new field, and so this has not been a long-term experiment where we can follow and go from our soybean to our wheat. That's the next step. We are looking at ways to establish treatments like that and establish experiments. But the data that I was showing you, that was, I think, the previous crop. I'm not exactly sure if it was beans that were growing the year before, and then we had a break early spring and then put in our buckwheat. Chris or someone else may be able to provide the exact previous crop, but it's me right now.
So there were two fields. One of the fields, it was the previous year before those summer annual or those cover crops were planted. It was corn. The other experiment did have longer term history, 3+ years of organic management. in that field, the previous crop was, yeah, actually the organic no-till soybean. So, cereal rye mulches on the surface and then, planting soybeans. So two different fields. One was, the corn was conventionally managed. The other field was an organically managed field with organic no-till soybean.
So the, that was the year before, and you were planting wheat presumably in September. That field had just been planted. That soybean field was not harvested. You just decided to plant wheat into it. It was kind of like, if you will, a fallow cover.
Yes, that's correct. We did not harvest the soybeans or any of the summer crops for profit. We also didn't plant the soybeans in May. The 3 planting dates started in July 12th. So the purpose of those soybeans, as well as the other cover crops, was not to use them for cash crops, but rather just as summer covers.
So if one took wheat off in, let's say, July 10 and planted the soybeans, obviously you wouldn't be planting wheat, but you had a potential to plant something in the fall.
Right. One approach here might be to go in, and if you have, have a crop that you can harvest in the summer, oats, for example, something like that, where you can go in and then get your buckwheat established. Some people can grow a nice buckwheat crop after wheat harvest, and you can think, okay, well that would make sense. I'd provide a window, but it doesn't make sense to go back into no-till wheat after that. So I think there is an opportunity here for these summer cover crops that, the buckwheat in particular, to be seeded. So July 12, that's, you might be able to harvest a small grain or peas or something else that you can get some value from, and then go in with buckwheat, roll down your buckwheat, and then establish your no-till wheat in September. So, but these rotation questions and putting the pieces together, this is what we spend a lot of time thinking about, and really that's the puzzle for us. So thinking about trying to maximize profitability, but also get these other benefits, in terms of soil conservation, improved soil health.
Two questions. One is, how effective was the rolling at killing those cover crops? And the other is, particularly with an earlier planting of buckwheat, is there a concern of volunteer buckwheat in the future?
Yeah, is that Rod? Yeah, really appreciate the question there. Excellent question. So I think the rolling was very effective at terminating. Of course, there was some regrowth of the buckwheat and the sorghum Sudan grass, but when we're rolling and then no-till planting our wheat in September, any of that that cover crop, in particular the buckwheat and the sorghum Sudan grass, that started to regrow or wasn't effectively terminated with the roller crimper, that just got frost killed, or at least with the buckwheat, it was frost killed. And then with the sorghum Sudan grass, once we got a freeze, then it went down. But so there wasn't any real regrowth. There was some I would say minor reseeding or seed production in the early seeded buckwheat. And we did notice some flowers. Chris may be able to comment on that a little bit more in terms of the potential for that. But yeah, when we're working with these cover crops and using mechanical termination, there's concern about the potential for seed production and that cover crop showing up where it's not supposed to be. When we're doing this with these summer cover crops that we're terminating right before our first frost, we get that added benefit of having some winter kill or frost kill there. But yeah, something definitely to pay attention to and to think about. For us, the buckwheat, the buckwheat volunteers the following year were quite manageable. But I think there was some of that, to some extent. So, Chris, any thoughts on that?
Yeah, nothing too much to add, Matt. I think you're pretty spot on. In the early seeded buckwheat, rod, which was seeded on July 12th, there was some reseeding of the buckwheat the following year. So basically, you had like some understory buckwheat growing beneath the winter wheat. But like Matt mentioned, you know, it didn't really seem to, it's quite minimal. You know, didn't seem to really be competing with the winter wheat, and the data would suggest that too. Almost like, you know, from what I recall looking at it at the time, it kind of reminded me of like if you frost seed red clover in winter wheat, like there might be more benefit than there is harm.
Would there be too much biomass to frost seed clover the next spring on the wheat?
Great question. I'm curious of the same thing myself. We don't know.
I suspect it would work, but I don't know. And you know, we don't have data on that, but I think, you know, that frost seeded red clover that tends to work its way down. And I can't imagine that the residue really blocking that or creating a barrier to that, but unknown or unconfirmed at this point.
I like the idea.
Great. Well, I think we've kept Matt and the Sustainable Cropping Systems Lab an extra half hour. So thank you so much for sticking with us, and really appreciate all the really interesting work that you're all doing. And I'm especially excited about all the new tools that are coming out to try to help us regain control of weeds. So, and especially in a reduced tillage way. So yeah, let's give Matt and the whole group a big hand. And who do we have next, Faye and Luke?
Thanks, Brian. Thanks, everyone. Enjoy the rest of the meeting. Really appreciate the opportunity here. Be well.
I know of is Rod wanted to talk about seed availability and what's going on this year. Is there somebody else, Luke? I think that's it. Say hello. You're the other part of the planning committee. Luke wants her to come next time so she can kick me every time I get up and say something.
Yeah, and I don't have a lot to share, except that I wanted to talk just a little bit about some cover crop mixes. You know, Kings has been involved with cover crops for a number of years now, and worked with a lot of different mixes, played with different things, and we've come up with some mixes that are a little more specific to the need and the desire. So we have one in particular that's kind of designed around the idea of being a cover crop to use prior to a corn crop. And we recently developed a mix that we found to be very beneficial and work well as what we're calling now 4 crops, right, Sarah?
Yes.
Prior to hemp or tobacco, or maybe some other summer seeded crop like that. So I don't think there's any magic answer to any single cover crop or any single mix. But I would tell you that when you're putting combinations together, it's a lot more about just any one of the single species in there. It's the combination of species that can really have an impact. It's not all about nitrogen fixation by a legume. You can get nitrogen supply from grassy type species in a cover crop too. But they're producing that in the form of organic matter that breaks down. And the combination also supports biology. So different physical structure of root to help soil penetration, and biology and support of mycorrhizae and those kinds of things all come into play. So, you know, any single species alone or in mixture is not the answer, and not the single driving force. So we've also been doing a little bit of work looking at forage crops and mixtures that take advantage of different climate conditions and season, and providing soil health benefit. And we've recently been working with and developed a mix that's been out with some producers the last couple of years that we call Yield Max, which is a combination of sorghum sudan with Italian ryegrass and some clovers. And that's showing a lot of promise as a forage crop that has soil health benefits. So I just wanted to mention those things. Another thing that we've realized is that some people may have a supply of their own small grain to use for cover crop purposes. Maybe you harvested some rye of your own or wheat. So you don't necessarily want to buy a cover crop mix from us that has small grain and all the other stuff. And so we've developed what we call booster mixes. We have a small box booster mix and a large box booster mix that you could purchase and combine that with your own small grain seed supply. So, of course, you all know that, termination, potential volunteer seed, hard seed can all be issues to be aware of, especially organic, and if you're growing small grains as a cash crop. All things. And lastly, just to mention in terms of seed supply, like everything else in this world, there are issues. The grains at this point is pretty good. The corn seed, soybean seed is not much of a problem. Our summer annual seeds are in pretty good supply. But all of the perennial seeds are tough. Some hardly any supply at all. Some just high priced and generally tight supply. Some of it is logistics, getting the seed into our hands. There was very significant seed production problems in Oregon, which is where a lot of the small seeded species are grown. And like in central Canada also is another production area, major production area, had severe drought. Really only other significant production area in the world is Europe. And you've heard what it's like trying to get stuff shipped. So it's just a real challenge. We hear every day about something that's more of a hiccup that, we're expecting seed to come. Now, either it didn't meet quality standards because Europe has different quality standards than we have, different noxious weeds than we have, or that it missed the boat, and now because it missed that boat, the next boat is going to be 2 months later, which is now past spring. So it's just a lot of challenges out there. But I think the key is, when you're working with stuff, don't wait to the last minute and be flexible with possibly some alternatives. So, I do think going forward, when we talk about cover crops, we're going to see issues with availability, later this summer. Winter grains, the weather was not good this fall. There's a lot of winter grain that didn't get planted. The other smaller seeds, clovers, vetches, radishes, the cupboards are either bare or they will be bare. And it's going to be dependent on whatever gets produced this summer, which is going to make it late available for planting, like late summer, fall. So it's going to be interesting like everything else. Well, I had, unless there's questions.
So I just have the MC there, his name was Matt.
Ryan?
Matt Ryan.
Matt Ryan.
Oh,
On the Cornell that introduced the speakers.
Oh, Brian.
Ryan Brown.
Brian.
Who that was?
He's with IBM, mostly out of Geneva. Is that right, Brian?
Yeah, I'm here. Yep. Is there a question?
Okay. Who was the other person?
Matt Ryan.
Matt Ryan, okay.
Getting our play card done.
Just want to add one other thing. That was at King's Agri Seeds. We did some trials this year. You alluded to that with our, what we are calling core crops. And the kind of the impetus for this was growers had difficulty getting their hemp seed to come up out of the ground. And most of the growers planted cereal rye. So if cereal rye has an allelopathic effect, the question was, does it have an allelopathic effect on hemp? And so we took this trial and we planted 15 different things at 3 different timings. And the results were remarkable. You could see a difference in height between the hemp and the tobacco that we planted on the same crop. It was like you were walking into different rooms. The results were remarkable. And if the tobacco was this tall, the hemp was this tall. They weren't the same. So the idea of cover crop seems to be very general. The idea of the forecrop is that you're really thinking about the crop that follows. And we don't have all the answers yet, but there's a lot, and we all know, to soil biology. And the mystery that's there, we're trying to iron out. We don't have the resources to do what Cornell is doing, with little snips and things like that, but we are looking at just the physical part. How does the plant respond? All of you read plants. Read that language, speak that language of plants. And we saw that in the ground. So we're continuing those research trials this summer with happening with other crops. Ron's right. We have a forecrop for corn, we have a forecrop for tobacco. We are getting to the point where we can suggest forecrops for hemp. And with any luck, we'll have other recommendations as well for different crops. So there's a lot to that. And weed suppression is just the beginning. Weed suppression is key. But then how does that energize the crop that follows?
Exactly. Yep.
You still partnering with your German company?
We are. Yep. So that's where our corn crop mix comes from work that they did.
Have you had experience with Versum?
Yes.
Is it viable for our area?
The question would be where you incorporate it into your system. It's an annual clover. So, if you're going to take full advantage of its potential, it's something you'd want to plant earlier in the season because, frost will kill it or freeze.
That's what I was thinking.
So
the legume that was winter fill for like spring wheat.
I think it would have potential. Yeah. I think that would have potential. But you'd have to have that window where you could plant it, And like Ryan said, that's sort of the challenge in all of this as well. Not many of us can afford to leave ground fallow that's not producing a profitable crop for a year so you got to try to figure out how to piece it all together.
When you take a legume like that winter fills, you don't have any idea for use. Do you lose nitrogen to leach in through that winter? Or do you need something to tie it up with kale?
Well, I think it would be definitely beneficial to grow something with it, partly for that reason and partly to get more overall benefit. I think, and I don't know if Matt is still on, I think back some number of years ago, Penn State had done some trials looking at like just clover as a cover crop that was plowed down or terminated and clover with other things. And they did find, leakage of the nitrogen from the clover only.
Yeah, I don't think Matt's on anymore, unfortunately. But if you could do us a favor for the online folks because we can't quite hear the questions. If you're able to repeat those, that would be awesome.
Sure. Just really quick on the other side of my business with Harold, Organic fertilizer, not much different than the conventional fertilizer and everything. You hear about that. So supplies are tight, prices are high. Some of it's just logistics. Recommendation would be don't wait till the last minute.